Good evening and welcome back to the show, Evening Rust, where we'll be doing Rust learning and coding game and competitions and all sorts of multiplayer optimization and everything you can imagine you might want to do with coding, other than perhaps something practical, except maybe the part of learning Rust, and that's what we'll do. So welcome back to the show. Yesterday we left off at our game. We managed to get ourselves to whichever one it was. Wherever it was, we managed to get ourselves in Mean Max into the Silver League. And we're ranked 72nd there, which is actually pretty good, I guess. And today we're going to go down and do a different one of these. Let me show you what that is first. We're going to be doing the Tron one. I don't know why it's called Tron. Everybody knows this one as the Snakes game. We have this. I've actually written this game twice. And I've written algorithms that do it a few times, so we should be okay. We'll get back to this in a bit. What we want to do is we want to warm up just a little bit. And we're going to go practice these general competes. We're going to take one of these challenges that we always lose, but it's fun to lose. We'll do the Clash of Code and see how it is. And I'll just do my intro until we're there. As I said, as always, if this happens to be a Rust thing, we will fail. Last time we failed because I just didn't get it right, not because it was Rust. And speed-wise, maybe. I mean, if we get lucky, we can get a speed one. Some of the other guys are very, very fast. And the reverse engineering we've not had yet. And I still don't know what flash means up here, to be honest. I just keep saying flash. And I don't know if that's the category or whatnot. And I just don't know. So I don't know for sure. We'll find out. If you're coming here from Coding Game and you're watching me, you can add me as a friend. I'll add you right back. And let me know. Just say hi if you want. And let me know if you have any questions. And if anybody knows Rust and wants to speak up during the show, please feel free. During the clashes itself, it may not be so good because it's really fast. But if you do see me stumbling, still feel free. We're not trying to win the clash, but we'd prefer not to come in last either, and we prefer to at least get the things solved. So it looks like we have a little bit of a deficit of people today. So if we really start with this with 3 people, then I'm really going to have a problem. And I am relying on having a bunch of random people and taking sort of the stats approach, which is hopefully getting not last. Anyways, about the competitions, the other ones, as mentioned by one of the chatters yesterday, something Russa, the approach we're taking is basically wrong. The one we took, that one, it's not completely wrong. I should say this, it's not, the structure's a bit weird, but we're doing the bits a little bit different. We're taking the approach of an expert system. Why kept hand coding if-then rules. And you generally, in AI, if you want to be able to learn, you don't want to do that too much. Instead of doing if-then rules, you want to have tables. And he spoke about genetic algorithms. I don't know how well that applies there, but in any case, if you did that or you did neurons, neurons are also a very simple way to do structuring code. And we might start looking at that today. The key to all of these AI things is, for these games, is some sort of scoring function. That's going to be the biggest thing, is come up with the scoring function. And the one for Tron today is going to be based on flood filling. Whatever they called it, some other diagrams as well, which I didn't know the name until I looked it up, but I've been using them. And it's going to be a bit algorithm heavy, but fortunately they're not very complex algorithms. And I'm hoping that Rust is fast, because in the Tron one, it really looks like speed is going to be the big issue, because the more we have to prune from our tree, the worse we're going to get in the algorithm. But I'm hoping, my guess is that we're going to get through the wood leagues with the most basic of algorithms, and that's been the case in the last one. We're simply going to do calculating the mouse space of ourselves in the next move and just completely ignore the opponents, and we'll probably be fine. But we won't know until we try. We won't know until we get to this warm-up, and we'll see what the warm-up is. So we have Niti, Swanee, Meatball. It's really... Could they not just show the whole name? Swanee, Evening Rust, and that's me, of course, and Mavenzi. We'll see how well they're doing, and we'll only see one. If this goes really well, we might do a second one if you want to, but I'd prefer to go over to the competition and we'll see what happens over there. I'm just waiting for this to start at 16. So we have a max timeout here. We're probably going to have 5 players, which greatly reduces my chance. We got one more in, so come on. If we get one more, our chances of not being last come up happy. Excellent. Come on, one more, so I don't... Okay. Perfect. That's what we want. And... Okay, we have to code as fast as possible. Given a chess position, your task is to determine the material advantage from the white player's perspective. The total material player has is the sum of the value of each remaining piece on the board that belongs to him. Each chess position is represented by 8 by 8 inches squares. Each piece is identified by a single letter. White pieces are designated using uppercase letters, while black pieces are lowercase letters. Empty squares are given as dots. The standard value of each piece is P. One does not count. The kings are not counted. An integer for the height of the board. A string of S representing the squares in that row. A single line with an integer D representing the difference between white's material and black's. The difference is 0, print equal instead. So we just count up numbers, I guess. I guess that should be simple enough. We're just going to have a big giant match here, which won't be so much fun. Okay, so we're just going to have 2 values. Let mut white value equals 0i32. Let mut b value equals 0i32. And we're going to say for C in s.chars, and we'll do a match C, and I guess we just had to stick all of them in here. Pawn becomes white value plus equals 1, and I'm just going to cram these all together. This becomes black value plus equals. I'm going to do all the blacks afterwards, actually, because it's going to be quicker. Knight is white value plus equals 3. Bishop, white value plus equals 3. Rook is R. White value plus equals 5. We're not going to question any of these values. Queen, white value plus equals 9. And anything else we can ignore because kings are not counted. So we're going to do the exact same for black value. We're going to put lowercase for all of them. That's going to say black was black. What is it? Yeah, black is the lowercase P, N, B, R, Q. And this is going to be black value, black value, black value, black value, black value. In the basic case, it's just going to do nothing. And that's all we add. And so in the end, we want to write the difference white materials and blacks. So let diff equals white value minus black value. If diff equals 0, we have to print something different. Print line equal, else. I'm hoping I understood the question correctly, otherwise we're in trouble and I have to read it again. Every time I have to read it again, it ends up going a little bit slower. And let's see if we got that right. Okay, let's see. Come on, man. So Amit's here. Oh, they must have given up. So actually, we got that pretty fast, and this all came down to, I think, the match. Knowing the match syntax certainly helped here. And without the match, that would have taken a long time. The cut and paste, I don't know if there's a quicker way to do it. How would I have normally done this if I had code? Because big match tables aren't really sustainable. But that one is not really that big. We have to know the cars. We could iterate over the character array. We didn't have to do an enum or anything. And we did no abstraction of any kind, which made this relatively fast. And what else was there to do? Let's see if there's anything else we can learn from the code. See, so these match tables, yeah, I'm trying to think. You know, honestly, I don't know how much differently I do this. You might want to have logic saying if uppercase, then it's a white score, if lowercase, then a black score, and then two lower and have a single match. And that would be a reasonable structure for a more advanced test case, but since we're just trying to do speed here, that's all we care about, is just getting the right answer. And the special case of diff equals 0 being equal, that's just a little bit weird. I don't know why they added that in. It's just like a little extra twist there. Don't know if that's that much value to the thing. And fortunately we have all the boilerplate, because this would take the longest. Oops, I didn't mean to correct that, sorry. And use size, so that was pretty good. And they do a trim right, that's fine. And I don't know, not much more to learn that one. I'm going to stick with this. We're definitely not going to do another one today, because I'm going to stick with my happy win right here. And whatever people are doing, they're having a problem with the score. So Amish just gave up. And was this one fun? Ooh, it wasn't exciting, it was fun. Difficulty? I think it was perfect. I think it was clear. Test case relevancy? I have no idea. I have no idea if the test cases. Did we have any situation or tested our code? Based on the other people, I'm guessing sure it's good. And we'll submit that. Now I don't know if we really want to sit around and wait for the other people to finish this. How much longer do we have? We have 9 minutes, so it could take a while. So let's go off and read the compete thing. It'll pop up as an alert whenever we get back there. So, now it's around 11. That's when I said I start. We're going to do this contest eventually, yes, as soon as it starts in 32 days. We have a lot of time to practice before I get there, so we're going to be perfect with Rust at that point. Just perfect, I tell you. And we're doing some bot programming today. We did mean max before. We're in the Silver League now. We're ranked 72nd, which means our stupid little algorithm actually makes reasonably well in the Silver League. And there's some things we're going to do offline to improve that, and we'll come back to that later when we have a different approach. But today we want to go to Tron. And Tron is snakes. So if you've ever seen the game of Snakes, and there are many different names, but always have to do with snakes. And it's right, light cycles. That's why they call it Tron, because the light cycles in Tron played the same basic game, and I recall that in the old arcade game as well, the variant that they had that as well. And the question is, how are we going to do this, solve this game? And they have weird things there. They basically give it away in the description of Voronoi diagrams. I think basically if you just follow their example, because Voronoi diagrams, if you've not seen them before, and I've not known this name, but I've used them before, and that's not the one I wanted. No, go back, previous, yeah. Oh, it's stuck somewhere. Previous. So I've used these before, but not knowing it. It's when you have games and stuff, you divide things into sections, saying how far each thing can get to, and they have a better example down here to the robots, and they use the contention for 4 is that B and C could get to 4, but D can get there faster. So the safer approach is for B and C to go to their own sections. And these colored sections are basically how far each person can get in that turn. And they show the little case of the snakes right down here. And it's doing the exact same thing. And the way you calculate this basic game then is that each turn what we're going to do is we're going to check each of our movements, every direction we can move, and we're going to fill in the area that we get to quicker than the other guy. And we're going to take the one that maximizes our area. We're going to have to estimate where he goes, but at first we're just going to ignore that and focus strictly on ours, and I'm hoping that gets us at least to the first league. And then as we go on, we're going to have to start judging, guesstimating where the other guy is going to go. And we'll do just probably, depending on the depth of this, we'll be sampling different trees based on 2 or 3 steps in the future, which one gives us the maximum output, and we might get in some Monte Carlo depending on how clever we have to get in the first leagues. So that's basically it. This is how the algorithm is going to work, and there's really expensive ways to calculate this and really cheap ways to calculate this. When you have a grid like this, the typical approach would be, if you have items of interest, you can simply go to each item of interest and calculate the cost to each of the person. And that actually makes it, if you have items of interest that are very limited, you don't get the whole area, but you don't care. If you need to calculate the whole area, like you do in snakes, because that's where our actual score is, we're going to use an algorithm that's basically a flood fill. It's going to be a cost-based flood fill We'll start flood filling in the closest distance first, and we'll do both players at the same time. So we never have any overlap, we never have any overwriting. Or we could have overwriting, but we're going to do cost-based. And actually, we don't even have overwriting. And it'll be relatively fast. And it's going to be the core of our algorithm because we really need that to be fast, because I'm assuming we're going to be doing it lots and lots and lots and lots, hundreds of times per second. And so if we hit a ribbon, we die. If we go off the grid, we die. And when you die, it's interesting as it disappears. So if you watch what happens here, as soon as blue dies, this line disappears, and that makes it a very interesting twist in the game. It's that if you can box somebody in, you can actually extend it, but that's only when you're calculating many things deep. All right, so let's join this game. Okay, there's only one wood league here. Division 2. Oh, there's 2 divisions. And bronze, silver, gold. And we'll see if we just make it out of the wood league today. There's only one opponent. We're going to read through the instructions first, but I think the same thing. We can only make 90 turns. Rules, information, location is sent in the standard input of your program, so your AI must read information in the standard input at the beginning of a turn. Your AI must provide the next move information on the standard output. The output for a game must be a single line stating the next direction of the light cycle, either up, down, left, or right. That seems very clear. Your light cycle will move in the direction of your AI provided. At this point, your AI should wait for your next game to turn information, and so on and so forth. In the meantime, the AI of the other players will receive information the same way you did. Now, they leave a little interesting hint here. We can probably totally abuse the fact that the other programs, I'm talking like if we ever get to gold level, that they take longer to decide. Because while waiting for input, if Rust has a way, and it must, to be waiting for input and also calculate at the same time, we could start running a simulation at the same time. And this might be very helpful. But if we have a fixed time limit anyways, if we're using up our whole time, it might make a big difference. Okay, 30 by 20 cells. That's interesting. That's it. We're just fixing here. Grid X, or so grid W equals 30. I32. Let grid H equal 20. I32. Be the last remaining player. Good. So, input for 1, 2 integers, N and P, where N is the total number of players and P is your player number for this game. The next following N lines. N is the total number of players, okay? The following N lines, 1 per line per player. First line is for player 0, next line for player 1. X0, Y0 are the coordinates of the initial position of the light ribbon tail, and are the coordinates of the current position of the light ribbon headed player. Once a player loses, his or below coordinates are equal to -1. Okay. Okay, so it doesn't give us the grid each time, so this is something we're going to have to track. I'm really curious as to why it gives us the initial position and the tail position. That's really weird. Why would it have to give us that? Input for 1 game turn. And why does it give us the integers for each turn? Okay, input for turn 2, what the other player gets. Whoa, wait. We take turns? Player number for this game. Alright, I just gotta figure this out. We actually seem to take turns. It's really weird. So we start with NP 2, 0. Input for turn 1, your turn. Output for turn 1, right. Input for turn 2, what the other player gets. Yes, they're all turn-based, but I'm getting confused here as to whether we take independent turns. It says what the other player gets. That's why I'm getting confused. Your turn. What the other player gets. This is what's really confusing me here, but it looks like we make a decision each turn. And 9, 5, 10, 5. So we just always look at the last number for each one, and that's where the person currently is. That seems reasonable enough. So we're just going to set up the grid first of all, and I'm trying to think what happens if we do nothing. So I want to read the grid into our matrix first, so I'm going to go get our matrix code. We have matrix code here somewhere. Did we use it for the mean max? No, did we? I don't even know anymore. We did not. So we used it for Minesweeper. So where's our matrix here? Struct matrix. Something beeped. We must have won or lost something. So we're going to start with some matrix code. This I'd like to know. Ryasora, you said you know some Rust. I'd really love to change this matrix code into some sort of parametric type, but I don't know how to do that. Right, we ranked 1. It's just... Oh, we'll just paste it again. So we actually did well here. We actually scored number 1 in our first game. So that's a wonderful way to start the day, because it probably all goes downhill from here, but we did a good job. We got 9, 6, and we should be good. We can share a code, I don't care. And we get some points for that. That's wonderful. Okay, so let's go back to competition. Where were we? Usually you put the last one we clicked here. Be quicker. Close this off. Oh, and we're going to actually go and just let people know that we're here. Because people love us, don't they? Okay, so let's throw that off over here. Building a Tron bot. Do that way. There we go. Doesn't appear to show up. That's fine, Ryder. We can get away with just a fixed matrix for now. I don't know what happened to my message here. Well, maybe they got the message, maybe not. What happened to it? Oh. We press send? Apparently sending doesn't work anymore. Come on. It's just weird. Their chat isn't working for us. Let's close the chat off. Open it back up. And see what happens. Alright, so we might not have many people joining us from Coding Game today because we can't paste into the thing. And I don't know. Let's just forget about it. We'll see who else joins us because we'll ask again later. And we'll just go back to here. Join. Continue. And oh, we lost the little grid thing. That's all we wanted. So grid width equals 30. Grid height equals 20. And let's go get our matrix code again. That was from Minesweeper. We had the basic of a matrix. And we'll have to make this parametric, I think. Let's actually try and do that right away, how we do Rust parametric types. I don't know how to do this. Generics. They're calling it generics. Incidentally, I get scared when I see these things called generics because generics are like a subclass of parametric types. And enum option T, T, T. This looks basic enough. Let's just do it this way. Implement submatrix T, and this will be a vec of T with implement matrix T. That's just fine. I'm going to push T. I'm going to call these cells this time. I thought I had another one of these that already did them differently, but we can just redo this bit. It's not that hard. T cells as use size, that's fine. Set T. Impl OK, like this. Okay. Why? Do you know why I have to do that? Is there a sense behind that, or is it just something you have to do? Alright, so we're going to do, we have the basic matrix, and each turn we just have to track where the person goes. And we're just going to output, first of all, we're just going to go to the right, and we want to output what stage everybody has on an oscilloscope. Okay, good oscilloscopes. And for each turn we have to have, but we have one state, we have one board state. So we're going to have the actual current board state. That board equals matrix. And we're going to make each board just be a number. I32. We could probably optimize that later. New. And will it... does this initialize to 0? I think so. No, it initializes to nothing. And we're going to actually want to say, in this case, put a second new. Let's have a fill function. Fill and mut self. The value, and we'll just for every single value. For I in 0 dot width times height. Self dot cells I as use size equals V. I'm going to fill it with 0. Board dot fill 0 meaning it belongs to no player. Maybe we should make it -1. Depending on what our player values are, we're going to make it -1 because the players start at player 0. They have IDs -1 and 0. Okay, right, so that makes a lot of sense. I don't think we're actually going to have to. Our cells, this is going to be a very basic collection. We're going to stick stuff in and pull stuff out. The actual cell values, I don't think we need to do anything with them. So it really, in this case, fits the definition of a generic, and we don't have to worry about the constraints at all. This could literally hold anything because nothing inside matrix is going to do anything. But what we might want to do is we might want to declare a type for board. So if you can tell me how to do a type def, I would do a type def of this right away. And we'd love to implement functions for that, but we'll see right away how it happens there. And so we're also going to have a game state, struct state. We're going to assume 2 players for now. Okay. Type board matrix equals matrix I32. Like that, and then I should be able to do this. Board matrix new. That'll work? Okay. So we have an actual board matrix, and this is just to separate it. And can we actually do stuff like impl board matrix then? That'd be curious to know. Or do we have to just pass it to functions on its own? So we fill it -1. Because, for example, the first function we want to have is we want to have a function called function dump board. And we're going to have the board matrix as and board matrix. And if we can make this sort of an impl, that would be really cool. But I guess not. Okay, it's just nearly. So we're going to do it this way anyways for now. We won't try to separate the board functions. We're going to use C-style object-oriented programming there instead. And we'll just do it this way for okay. Makes sense. In this case, I really want it just for this type because we'll see for dump board, it's really strictly for board. But that's a good thing to know that we could probably do. Let's try this first and see when it first compiles whether this fails for us. Or we can also say just matrix I32, what happens there. I don't really need that yet, but where'd it go? Let's put it there for future, for posterity. So row in .bm.height for column in 0.bm.width. And we're going to assume less than 9 players, so this makes sense. And we're simply going to switch on that value. So we're going to say if, so let v equals bm.get. And what do we say get is x comma y, so c comma r. Alright, and we're going to try this match now. This is one I've been wanting to do. If we do a print, do we have something other than a, do we have just a print instead of print line? I've never actually used a normal print. And we want to do a match on V now. And this is the syntax we got to the first episode that was giving us trouble. So we're going to say if it's 0, actually if it's -1, okay, we're going to put a dot, and if it's anything else, Q, we're going to print out Q plus 0. Okay, how do I convert this Q to a number? I want to convert the integer to the number 0 plus 9. We're assuming there's less than 9. And this will have to be, well, what we should do is Q. Q is U8. That whole string, both of them, we can't just do as char. Well, we'll see what that happens. And then we're going to dump the board. This will be enough code to see that we've done something right now, and the game's going to whine at us right away anyways. I just want to see that we can compile first. And our tiny little output window. Expected type found, blah. Okay, I make this mistake a lot. Let me tell you why I make the mistake. Because in Leaf, the language I'm writing, functions are denoted by this symbol. You don't have a function unless you have this symbol, whereas in Rust, they're denoted by the fn, and if you don't have a return value, you leave out that symbol. Hi, encoding. Nice to have you back. So, if you see me doing this, you'll understand why it's getting instinctive at this point, because this is my syntax in Rust, and it's going to, or in Leaf, and we should probably deal with it. It'll go away eventually, maybe, or maybe not. Okay, where we have 33, fill is self.width, self.height, and print error, we don't need that. Can we turn off the unused macro warning? Turn off unused macro. If anybody knows how to do that, we'd love to turn it off here, because we don't want to get rid of that yet. No, I don't want to allow all warnings. I just want to allow the one. Can I just allow the one? I'd rather turn on all warnings, allow... Can I just do allow unused macros? Well, I'll try that. And what I'd actually like is I saw somewhere, I want to turn on every other warning though. Where did I get that? My cheat sheet. Where did I see that? Mean max. I lost it. I had it somewhere before. What I actually want to do is I wanted to convert all warnings into errors. Yeah, I want that. Okay. Do you know the one that converts all the warnings into errors? That's the one I want. Other than this one here, I want every single warning. There we go. Thank you. Because we have this issue with coding game that if you don't have any errors, it doesn't show you any compiler output. So we prefer to always do it, and we want it clean. Okay, good. Expecting one type argument. 26. Matrix T. Alright. No field named rooms. That's okay. We forgot to change some of the text. Cells. 49. Cells. 74. Okay, so this operation here, Q is U8. Doesn't like that. So we're really going to have to do this probably. I think this is what you meant, as U8. Well, you can just say as I32, because we already have an I32. And say as chars, the whole thing. I think that might be what you meant before. And I just got it wrong. Board matrix grid 2 parameters, that's correct. Grid W, grid H. Only U8 can be cast as char. Wait, is char like only ASCII? Can you not do Unicode? I mean, I'm totally okay with this. For our purposes here, it makes no difference, but that's fine. I just want to know. Oh no, unused. Oh no, now it's going to get pissy at us. We're going to have to get rid of all these warnings. But that's good. We want to learn this on line 98. We want to be perfect little code here. We don't use this. So we can just skip this let. Okay. We don't need to get the player number first of all. I hope it lets you ignore return values. And we don't need the line number. I think underscore gets rid of that. Okay, I got it there. And for all of these, we're just going to disable them for now. Is there an ignore function in Rust? Can I ignore something instead? No, move occurs. Okay, now we have this one exactly here, 36. Equals V. Fill. So we're going to need to clone on this. Clone on that. And we might as well take a reference to it. Cannot borrow mutably, 89, yeah, fine. And so over at 89, we're going to have to take a reference to it. And -1 looks really weird, by the way. Okay, now how do you do this part? Let's do that for now. That makes sense. Thank you. When you come back, you saved me lots of effort here. So 89. So this one we might be going a bit slower. That's fine. We really want to get the Rust correct now. We can't just make this up. Cannot borrow mutably. Alright, that makes sense. So we have to have a mut board Alright. Linked libvine here, and this is good. Method is never used. Oh, that one's stupid. That's a stupid warning. I'm sorry. How do I disable that one? Notify. Allow dead code. Well, this seems a little bit restrict. Panicked. Panicked. Good, good. We panicked. Alright, this is because Phil here. What we have is Phil. Is we want to look up is we have to something do with the self.cells. We have to at least reserve something. So let's check up the array. There must be some syntax for this. Do I have an API guide here somewhere? Where is it? Rust API doc. With any luck, we even have a... We probably have a fill function on vector. Now let's look at the other vec. I'm never quite sure. Standard vec, standard vec, standard vec. This is contiguous array written vec-t but pronounced vector. No, sorry Rust, you can't do that. You can't call something vec and then tell us to pronounce it differently. That's just not how programming works. Sorry, I'm going to call it vec. I want to just fill an array with stuff. And the issue is because I'm filling it here, I don't have the right size. And reserve. So I just want to make sure their size. I want to resize this array cells to be the exact same size. I want something like capacity or something. Set capacity. I don't want a new vector. I just want this vector. I want to reuse this vector. I just want to reset it. But to reset it, I don't want a new one. I just want to reset it. There's no fill. So you happen to know what it is? No, okay, with capacity from row pointer capacity. What does capacity do? Reserve. I don't want capacity, I want shrink to fit. No, that's not it. Truncate. Now I want extend. Extend and truncate. Alright, we'll do that. Seems a bit inefficient. I guess it's probably not inefficient because it's keeping the same thing. Extend 0 map dot height dot map an unused vector, and we want to type v. Okay. That looks more functional. That looks better than what I had. And unclosed delimiter, that's fine. No, I want this now. You gave me something better and I'm sticking with it. Map. Cells extend. Okay, this is a double one right there. Alright. Oh, we have to output that print line. We should probably print this to error, print error, print error. Oh, print error line doesn't print. It always just prints a line. Print error line, and this one would just be print right. Alright, I just want to see my board. Alright, you can stop now, game. So I'm just going to die. Just stop. I don't need to see it. Show me what I had written out. Alright, so we initialized the board. This is all I wanted to see, is that our code's compiling at least. We have at least the initial board output. And then every turn I'm going to dump this again so we can see where the players are. So on each turn, what do we have? On each turn we're going to set feel free to paste links. I'm still trusting at this point. As long as I can recognize them. There has to be a domain I recognize. Okay, so number of players, parse input, loop, game input. What is this again now? For each player, starting x coordinate of light cycle, or -1. Starting x. Well, they just gave the exact same comment. Excellent. ePrintlen. Is there also an ePrint? Hello, Studio C. So we don't need ePrintline or print airline, so print airline. We have an ePrintlen. Is there also an ePrint? I'm just going to assume yes. Let's check that out. ePrint. There it is. Good. I want to test that out. Rust ePrint. Glad you noticed I'm using DuckDuckGo. It's my favorite one. It works so well. I love those things. And great. So I can know with it Rust ePrint. That's perfect. So we print the board, we print that, so we can get rid of this stuff here. We don't have to worry about unused macros. Go away. I don't know what crates are yet, to be honest, so I wouldn't be searching them. I see lots of mention of crates in Rust, but I really have no idea what they are. And I'm trying to figure out what these values are. It contains 4 values. Coordinates of the initial position of the light ribbon tail and coordinates of the light ribbon head. I'm really curious as to why they give us tail. Why on earth do we need to know that? So they're just confusing me. I don't know why we need X0 and Y0. Your player number, so we're actually going to need to know. And I'm going to make this P as the player, and so now we're going to say board.set x1, y1 to P. But that won't help. There is no max length, but even if it did, it wouldn't help because we have to track the entire path on our own. And so we're going to do a dump board and board. All I want to see is where we have the same path that the guy has. We don't know what player or character we are. I'm just going to do the basic thing that we're reading and input correctly. Expected I32, found size. Well, then we'll just make this an I32. Lost. Incorrect movement. I'll play again. I need to see something with other random output. Okay. Alright, so that looks like the board. No, go away. Ah! So it looks like we have the basic reading here. We're setting the board. We know where the things are. And this is going to be vitally important for the next step where we actually decide what we want to do. And okay, so we have this. We dump the board. And what player are we? So now we're going to create the state. So we had the state. And the first thing the state wants is a board matrix. And how do we do this again? We have the board. It's a board matrix. And we impulse state new, and this has to have an x I32, and well, I'm going to call it width again. Width I32, height I32, and this returns a state, and this becomes a state with a board being board matrix dot new. I don't know. I just don't know. I really don't know why they have -1 there. Maybe one of the advanced levels it changes. We had this in the other game, that they gave us a bunch of stuff we didn't use in this version, in this league. So it might come back later. Okay, and unlike the other games, actually no, I do the same thing. We need a struct point here as well. Point 2 is going to be I32, and we might have to change the matrix to make this easier. It's unfortunate there's no overloading or rust, but we'll have to deal with that. And we want this for point 32. We want all this good stuff on that thing. What was the thing we put on those? Yeah, this type of stuff. Point 2, why did it go away? Point 2 is going to be clonable, copyable, debuggable, but not partiable. The state is going to be clonable and copyable. Actually, it doesn't need to be copyable. It needs to be debugged, and it does not have an order. The matrix might need to be clonable. Should not be copyable. If I understand, copy is like a Lowes copy. It doesn't need to be partially derivative. Okay, and where was I? Oh yeah, that makes perfect sense. Okay, it doesn't need equality either, so we're okay with that. We might, but probably not in this version. Copy means it can be mem copies of clone. Okay, we don't need that. That's why I assume copies like it does kind of a shallow type of thing, but that's not what we need. Our clone's going to actually have to go down and clone this stuff down deeper. Now I'm just wondering if we keep the players in. Okay, so we have our player. We have player ID. It's I32. And we have heads. This is going to be a vec of 0.2. Okay, but I think we just want clone. We don't want copy, we just want clone, but that's good to know. So when I say something's copyable, we don't actually have to write clone as well. I guess that's what you're saying. And player ID, we don't have one yet. Heads, we'll just create one. There's nothing in there. This is a little bit weird. And okay, so we're going to do this. So for each one, we're going to have, we need a state here. Let mut state equals state new. And this is with the grid x y. And the state.board.fill state.board. And actually, I'm going to put a state dump as well, state.dump. So we have good output here. We'll have one dump function that does everything. Function dump and self, dump board, and self.board. And I'm trying to think of how we'd mark that on the table. It doesn't make a difference. And I'm going to put this all into a state read function. Read step and mut self. And this comes from standard in, which always feels a bit uncomfortable, but I'm okay with that. Then we clean up our main loop. We're going to set this up correctly the right way. String new parse input number, total number of players. And I think this might be an older game because they give us the total number of players every single turn. That's weird. 2 to 4. Maybe the number goes down if somebody dies. And your player number. Whatever. I'm still not quite clear on their instructions, but I know how the game's supposed to work, so we'll do this. Total number of players, and we're going to do self.heads.clear. Self.player-id. Oh no, that's not correct. I hope this never changes, otherwise we're in trouble. We're really in trouble if this player ID ever changes, so I'm going to assume it doesn't. Self.heads.push point to x1, y1. Now we have the heads of all of them, which is good, so we read the step. So we can do state.readStep, state.dump. And now we have to figure out what our action is. And so the first one, just to get it working, is I'm just going to choose a direction where a person can safely go. And I just want to see it work so far. Once we do that, we'll actually start doing the filling algorithm. So the first one is based on the player's head state. Where can we go? We can pick any direction we want. And I'll make a separate function for now, not in state. And next direction. Sorry. State and state. And we're not doing it mutable now. And this is actually when you're doing AI, especially with AI and scoring and stuff and working with data, languages that allow you to declare stuff as immutable are really, really, really helpful. It's one of the things that's frustrated me with working with things like C# and Java in the past, and even Python and stuff, is that when you're trying to deal with data and you really want these functions where you have read-only functions, it's really helpful to have these immutable types so you don't accidentally change them. And it gives a very nice contract to them as well. And we'll make this one return a string of some kind, or we'll just make this one printed out. We're probably going to have a direction in there somewhere. Actually, that makes sense. We're going to have a direction, so let's do enum direction. And let's say right, down. I use this direction. Left, up, right, down. Doesn't matter what it is. Okay, so we're going to do some point things here. I'm going to move this back up because what we need is a bunch of helper functions on point. And I thought I had it implemented somewhere else, but this gets become very common. And now we're really going to see the advantage of immutables here, which I really love immutables for this purpose. Implement point 2. So we're going to have a function, and we're going to do step and D in direction. And we're going to say and self. And it's going to return a new point 2. These are all immutables, so what we end up doing is point 2. No, we want to do match D 0.2, where am I? Self.0 minus 1 self.1. Yeah. Up is going to be 0.2 self.1 minus 1. Right will be 0.2 self.0 plus 1 self.1. And left, no, right, down. Down is going to be 0.2 self.1 plus 1. And I really like immutable, so basically we create the high-level vector type 0.2, and we can just abstract all of this stuff away and check where it is. But the issue here is with the matrix, since we don't have overloads, and that's unfortunate, we can't have a get function that has both an x and a y and also takes a point. So we're going to convert all of these to taking a point and just say location is 0.2. We'll say location.1 plus location.0, and set's going to be the same thing. I really wish there were overloads, but oh well. I'm not going to change that. And isValid is a very useful one. isValid we're going to see right away. IsValid just a low-level valid. Is this actually a valid space? Lock.0. Lock.0. Lock.1. We can do overloads? Oh, I think I get what you're saying. I was just hoping to do simple overloads here. Oh, you're saying the overload would have to be a trait of 0.2. I'm going to have to come back to that. I can't quite follow that right at the moment. So these things we're just going to do 0.2. It's the only one we use, so it's not a big deal. And we're probably actually better off doing this. Tail equals 0.2. We have this type. Let's just use it for everything. Just get rid of that. And this is copyable, so we can just do this. Push tail, push tail. Okay, and next direction. So we need another one. Got to say board is free. So these feel like member functions on the board matrix. We're just going to make free functions for now, so we don't know if we can implement that on a type def because it's just a type def. Board is free, and we want to say location 0.2. This returns a bool. And so, of course, if bm dot is valid lock, if it's not valid, then we return false. It's obviously not a valid location. It can't be free if it's not a valid location. All right. I don't know if we need that, though, because we already have that in point. That's why we put it in point class. In the point type, we did a step function. That was the purpose of step, is taking direction. And that uses the pattern syntax. So, or do I get that differently? Isn't that, I think that's what we did right here. And so next direction is going to be readable just by the justification using step here. We haven't actually done next-dir yet. This one's going to have to check each of them. And so now we're going to say let v equals that's what you mean. Let me check that again. So you can do that. Interesting. So we'll do that then. And so this is like a... Is this like a pattern extraction? So it takes this point and extracts the x and y? Because that is definitely more readable. Okay. We'll have to get into that. I'll have to understand that a bit more, because that's actually really nice. It's like a pattern matching, and the pattern matching basically says we take self, it's a reference to point 2, but we break it off into these values which are mutable inside here, and then we reconstruct it. And so that step then is a lot cleaner. It becomes mutable then. That's totally what we want. So get location. Now we simply return v equals 0. No, v equals -1. We said free is -1. And do we know how to declare constants? Let's try this out. Rust const, or is that just a let? Let's keep using -1 for now instead of constant, but constant would be clearer. Whatever. We'll use -1 for now. Next direction. So our next direction becomes this. For d in... Can I do an in an enum? D in direction? Const free. Free cell equals I32 equals -1 I32. Might as well. If you give me a suggestion, I will use it. Free cell. Free cell. I'm sure we have another one in here somewhere. Free cell. Free cell. So I'm hoping this works. D in direction. Can we enumerate an enum? Oh. Well, what's the macros? I want to iterate over any num. Or do I just have... Is it quicker just to hand code it because there's only 4? Like to do something like this. Direction.left. Direction.up. Direction.right. This probably makes more sense because we can control the direction. Reason why I'm not using an option is because I know this part of the game, and it's a premature optimization, but I know it would be better, is that it's going to be extremely vital that this is going to be fast and tiny, and actually we're probably going to replace that I32 value with an I8, because it might make it faster, because we're going to be evaluating these cells probably thousands of times each turn, so anything like a wrapper for an option and stuff is going to be overhead. And it doesn't matter how fast option is, it's going to end up costing us turns later, so I prefer to do it without right now. And even though if I were doing a generic data structure, it makes sense to have that, but we're just going to do it this way, and we have a lot we can store in there. Down. And I think I need to take a reference to that. I don't know why, to be honest. So we're going to say next point equals state.heads, state.playerID, dot, what did we say it was? Step in D direction. If, So it's taking the C++ approach to static values. Okay, cells BM is free. Next direction is obviously going to need a board state. No, state has a board. If board interesting. If these weren't such basic names like left, up, right, and down, actually, let's just do it, just so we learn. I don't care. This is a small enough function. It's like this, use direction star. Why not? Is this scoped? Can I put this inside a scope if I wanted to isolate where it's in, or is it for a function only? If board is free, state.board, the next position, then we're going to state next direction. Actually, it's return state. We will return D. Sounds good. Otherwise, we're going to return left. We're dead anyways. Doesn't matter. If there's no direction, it's because we're dead. Var D equals next direction. State and state. And we can make a function to emit state now. Emit direction, and we have a D, which is a direction. We're going to print line. We can't do anything else, so let's do it the whole line. Match D. Left becomes left. Up becomes up. I always forget how much work there is setting up these things when you start a game, when you start any type of program, if you want to do it right, the amount of actual initial setup. And these are always the same between these games, so I really should start copying more of this code even, because we're going to have the same thing over and over. There's a lot of grid-based games, but this one I'm happy with. We're doing it correctly for a change, so let's actually we'll start doing this one. We'll start with this one. And let's see what happens now. I mean, once we get the errors gone. Oh yeah, var. If you're wondering why I type var a lot, because again, that's in Leaf, that's what the default is var. I do have a let, and let actually means the same thing as in Rust, but var is the same as a let mut. So in Leaf, var means let mut, essentially. Not quite yet, but okay, 63 and self. Okay, I didn't like this. Did you mean Alright, so it doesn't like this syntax here. That was recommended, the pattern matching one, but that's the one we got from the playground. I thought. Why did it not like that? So it doesn't like this syntax. Whatever that is, it hates. So if you have a fix for that, that'd be wonderful. Otherwise, I'll have to go back to my crappy version. And 186 was the same thing, 54. Copy, so direction we need a copy as well. Wait a second. I thought you said we don't need clone if we have a copy. And this seems to be arguing otherwise. Alright, the error message is up here, 63, line 63, this horrible thing up there. Sorry, I can't actually make this bigger, actually make this tinier. Especially if it says, did you mean self? There's the message right there. bm.get, okay, that makes sense, 127. I don't think I understand that comment, Ryasaur. Yeah, I know that's what it suggests, but it seems suspicious. Like self as a type. Alright, what do I have here? The other ones seem to be straightforward. State.head, state.player-id. Oh yeah. Capital S self. Aha, okay, that makes sense then. 153, return D. Next direction has to return a direction. No method called step 2 or step for point. Point 2 has a step. Huh. Now it's bad that it doesn't find that. Because it says no method named step found for point 2. We have point 2 and we have a method called step. But it's not recognizing this as a method on point 2. Must have a self parameter. Okay, so I don't think it's accepting it as an actual parameter then. Or something's changed, so it's not recognizing this as an actual function on step or on point. Okay, what is 153 the problem here? Return D. I'll just go away here. Let's try it again. Let's see if we have the one-way message left. Okay. Understood. What exactly is that? So this equals self. So is it like this? Yeah, I mean, is this the correct syntax here? I don't really know. Okay. Alright. Direction 4 is not an iterator. Alright, so that's the one we don't understand. I don't know. How do I get this to work? I want to iterate through this vector here. It's saying it's not an iterator. Maybe try calling iter. I'll try calling iter, see if it works. No. Or maybe. Come on, stop going to the top of my file. 152. Expected enum direction, found and direction. Why is it finding and direction? Do okay without the iter or with the iter? All right, just a second. With iter, okay. Thank you, Tris. So what is it saying now? And just as a reminder, I'm not being an idiot with this window here. I really can't make this any bigger. It's kind of annoying. It has this totally useless side thing here, just consuming up space. Alright, so we'll try that. So without that, and reference, point to D, point to D. Type direction cannot be dereferenced. So I just really get confused. So it's not point to D. If you have an and D, it's not a point to D. Or what is that? I think you got it. We got further, so I think we got the right pattern matching there. It's going to be... Oh, I have a weird message over here. Just a second. It's going to be a bit weird for me getting used to that. But, hello, Winter Squirrel. Thank you for joining the show. Left. Okay, this is the gear. This is actually the reason why here this match. Why we have this deny warnings. Because otherwise, all of these things do something, but they don't do what we want. So I'm going to stick direction left, or as we said, we can use direction star. Hope that fixes it as well. 164. Use direction start. Yeah, I have to get used to it. It looks sort of like pointers and references and pattern matching. I'm just not clear on how it all works together yet. That's why it's good we're forcing us to do this. Oh, look. So I think we're player 0. We won. That's really... So this first player here... No way. It can't be. Let's just play it again. We don't even have an AI yet. All I do is when something's in the way, I stop. So I guess we're that color. Who knows what color we are, to be honest. So the boss did something different this time. Even in Rust lost, incorrect movement. So we must have a defect because we shouldn't have made an incorrect movement. Let's do high quality too. That's really helpful. You guys like high definition that takes half the size, yeah? Well, let's see what happens when it starts again. So, we must have something wrong. If you want to remove the boilerplate for capitalizing the variance, which variance? Okay, that's good to know, but there's a very good reason why I wouldn't want to do that. Because I think it's a very limited case that we're outputting an exact state that matches the internal state. Yeah, I know which one you're referring to, but I actually, in this case, I don't think that's a good idea. I think this makes more sense because if we looked at all the other games we did, this is relatively rare. Usually you write something else, like an extra value and stuff. It's just in this weird case, and I don't actually think internal game logic should be directly mapped to the API. I think this mapping actually makes more sense. So I totally see what your code does, and that makes sense, but I have a feeling that in this case, this makes more logical sense in terms of what the code is actually doing, because we may have actually had something like left 2, or this may have actually been an output of like left, and I don't want the output API to influence our internal code. And so like in some games we had L and U, for example, and so that's why I prefer to keep it that way, is to not have a one-to-one match. But yeah, thank you for bringing it up, and I'll keep some of these playgrounds open so we have them. Okay, but now we have an actual defect. we actually didn't turn. We hit 0 here, and we said left. Who knows what reason we said left. And because we had nothing free, so we turned left by default. Step, step, D, step. So something with step is wrong here. If board is free, log point 2. If it's not valid, return false. Otherwise, we get the location and we say if it's a free cell or not. So down should have given us something. We should have had a down. And why did we not have a down? Let's check the code again. We have a step. Let's double check the step function. Okay, that's the problem. Down is +1. So we made a mistake when we did the simpler format. So let's actually trust. Let's just put full screen this time. Alright, so we do something, and I think we've probably matched the exact logic the computer has. Well, maybe not. I can't actually see ahead who wins and loses here. So with this bot, okay, so we win, but we just got lucky. We just got lucky there, and I'm guessing in this Wood League 2, we're going to need to use one scoring function. That this is obviously not enough, but let's just see. I'm just going to try it. I'm going to see if we get lucky. It's like really ridiculous, but no, I can't be winning. There's no logic here. How can I be winning? That must just be the bottom of the leaderboard. Okay, so that's the bottom of the leaderboard. This is probably a whole bunch of people that are at the same point we are in the code. Just no logic. And we win against no logic. And as we go up the ladder, we're probably just going to get stuck. And the first scoring function we're going to do is just calculate the score based on where the next step is, what gives us the highest score. And that's where our actual first algorithm comes in. Yes, right, so that's what I'm guessing too, is that, and we confirmed yesterday that we actually get matched against people at our point in the leaderboard. So if we're right at the bottom of it, and we're going to get matched against easy people, and those are going to be people exactly as you say. They just got their code running. They did exactly what we did. They came in, they said, it works, we don't crash into a wall, let's submit it, and we'll have to see. The question is, will we actually do better than JarVBoss? JarVBoss is good. It looks like we will. That's like weird. And so that's just really weird. I actually expected we'd have to do at least one score function to get out of Wood 2 League. So I guess in Wood 1 League, we're going to write the score function. That's what we'll do right away. And we'll might as well let us start finish here to get out of this league, because we're going to win by a long shot. But okay, maybe this is fair. Maybe this is fair because I'm really used to this type of game with graphics and these little grids and the moving around. We're going to have a lot of people that are new to this, and actually just mapping it and keeping track of this map is not a simple job. It's one of those things, if you look, we took over an hour to do this, so if I gave somebody in an interview that's never done this before, they'd have a problem. They'd be struggling. I mean, I couldn't get it done in an hour, especially not in Rust. I could definitely get it done in an hour in C++ probably. Python, maybe. C#, probably not. But Rust, definitely not. We're willing to know our Rust, that's good. And we should jump up the league just fine. Now this is where we're kind of in a dead spot. We want to actually get to that next league. And like this is... Okay, so this is actually kind of disturbing that most of these things just don't appear to hit the wall. Because we have, again, zero logic here. All I do is check to see which next cell, the immediate next cell, is free. There is more additional logic to this. I don't check where the opponent is. I do nothing. And so this Jarve boss must have intentional errors in it. Maybe it does something random. Maybe it goes until it hits a wall and then just gets stuck. I don't know. It may be just because we got lucky that I prefer going left and right, that we don't make a big box. I just go left and right and do a flood fill somehow by accident. Let's see what other languages people are using. So Python 3 is very common. That's what the somebody's using Scala. Okay, so I wonder how the server is. Anybody using Scala on this server, if you know if the compile time's really good, or does it have to actually launch the VM each time? Python 3 is probably okay. PHP, we've been seeing a lot of this. A lot of people using PHP. So they're coming probably from web backgrounds. JavaScript, we've seen a lot. OCaml. Yeah, okay. I don't know if OCaml is a good way to do these things. It should be. It's going to have a lot of that immutable data structures too, which are really good for these things, except when it comes to optimization and looking forward for scores, you're going to want mutable state because speed is extremely important. We're not there yet. We've done absolutely nothing, so speed isn't important yet. But we have a huge advantage over the first boss. So we might actually get to a decent position in the Wood 1 League as well, with, again, no strategy. So we have a C#, a Scala, a C. Hey, there's somebody else doing Rust. Hello, RemRam. Let's just say hi to them. Can we stick to them? Let's follow them. They're level 5. Let's follow them. We can't send a message yet, I think, but okay. Whatever. That's good. Let's just follow anybody doing Rust. If we ever see any more. Java, Python, C#. Anything else new, interesting down here? Groovy? I don't know Groovy much. I think that's a variant of Java, isn't it? With special syntax. That's the one where you do if type is some interface, you can use it as an interface inside that structure, something like that. Python, JavaScript, PHP, blah, 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 nothing else new. Come on, something else. Give me something else interesting. In fairness, if you're looking for, say, a job, practicing for interviews, taking the standard staple of languages makes a lot of sense. You're not going to have a lot of positions for Rust interviews. Go, there's a Go guy, great. Ruby, Enclosure, another fun one. And Scala, what else do we have? Wow, there's a lot in here. Not more I can see, though. Anything else? Do you even know any different ones? Bash. Why? Did we get promoted or something? I think so. Yeah, Wood League 1 but 1. Good, we did all of them. We were promoted to the next league. Wood League 1, let's just submit it again and see how badly we do this time. Did you guys see that one? Somebody's actually doing this in Bash. Now why? Why would you do this in Bash? Yeah. I think I have to get to the higher ranks to know that, though. Alright, let's see what's down here. We have a lot less people, I think. Anything new? I got excited there was Rust, but that's me again. Nothing else new this time. VB.net. Wow. Wow, that's like really... I haven't seen Visual Basic in a long time. You can actually do VB.net. I guess you could program this one in an Excel style sheet. That would work well. It has the output format. Haskell, another functional guy there. We have a very... distribution languages is very focused on the main ones. An F# guy. Hello, functional person. And so a lot less. So there's a lot less people, so clear people are having a bit of an issue. Same as me. Nobody. We're the only Rust guys in this league. That doesn't mean there's not more in the higher league. No, I haven't done any of the challenges. I guess there's a lot of people doing it for the same reason we are. Same reason I'm using Rust is because it's something you don't know. Let's just do it, or it's a bit of a challenge, and we can see what it is. Okay, guys, this is disturbing. How am I getting this high? I'm almost hoping I don't make it past this league. Like, we better not go too any higher, because this is simply having a working board tracking shouldn't be enough to make it to the Bronze League. We're going to find out, though. mort-ora-y is quite a bit higher. And we went down. It's okay, so we may be stuck now. This looks good. We might actually have to do the scoring function. And the scoring function is where it actually gets fun. But we actually got up a bit. Well, let's see where we end up. Let's just ignore it. Our rank's up here at 9. Again, this is a 9 with no actual strategy so far. I mean, the strategy has simply been check the pieces in this order. Where's that order? Left, up, right, down. We always check in this order, so if that's insufficient strategy, that's kind of scary. What we need to do now is not check if it's valid. We actually want to check the score at each one. And look at this, we still went up. 6. So what do we have? We want to score it. No, seriously, we're at rank 3. That's not right. Guys, that's just not right. We don't have a strategy yet. Yeah, like, why? Why? We don't have a strategy. This is just like the minimum working code. Which means that simple one-step count is probably going to work well enough. But we have to implement that. But I always want to wait now to see where we are. But it looks like we're not going to catch the boss because we're going up and down here. So if we look at the battles, we're getting fairly mixed. So we'd have to get quite lucky to see what happens now. Yeah, this is not enough to get in. Usually we have to get quite a few mixed ones. And look, we've clearly lost this one because we're orange. They're not filling it with fake entries, but people may not be updating them. Right? These may be entries from a long time ago as far as I can tell, and they never take them out. I have to compete against all those entries from before. I think that's how it works. They may remove them inactive at some point, but the ones at the top, we never know. Kigwen, maybe they just gave up. Did they come back recently? Who knows? And we just don't know. But there is activity here, so I'm not so concerned about that. I wonder if the commenting works yet still. No. Go away. That was bad. Now I'm stuck here. I'm stuck in no man's land. Okay, so we're probably not going to make it, and I'm going to copy it now. Do I actually get a message in? Let's see if I can send a message. I wanted to send one before. We're building a simple Tron bot. Unless they don't allow URLs anymore. Ah, there we go. That works. Perfect. And we could probably just keep running this getting lucky, but let's actually assume we're not going to and start building the next one. And what we have to do is we have to score... Alright, so we want to score position, and we're going to take the state, and it's going to be and state, and we're going to take the next position, so location, let's take position. I'm going to call it location. We've been calling it location most of the time. I don't know why. Location is a 0.2. And it's going to have an I32 value. And so we're going to have a let mut best direction equals none. And this is going to be an option of direction. Let mut best score equals 0 I32. And now we'll say if the board is not free, we continue. And instead of making this none, we're actually just going to say left. So the fallback is left because we fail. And return best direction. And so our score is going to be let score equal score location and state. The next position, I gave it a silly name. Well, it has to have a score of at least 1. Let's just say -1 so we take care of that case just in case. If score is greater than best score, then best direction equals D, best score equals score. This is a very common thing you'll see in our things. So this is our basic AI loop. Every single turn, we're going to do the same thing. Look for the best score, score location, and score location is where most of our work's going to do. And it looks like we probably failed out here now. Our battles are done. We're not running anymore. No, we're still running. But no, we don't have the little marker, so we're actually done now. But we have other people competing against us, so it'll still be a bit more. But I think all we have to do is the one basic score location. And so let's do this. Let's score mut score equals 1, because we have at least one position, I32. At the very end, we're going to return score. Or we just say score. I actually don't know what syntax is better. I guess this is the Rust syntax. Now, what we're going to do, this is where we're going to create a secondary matrix now. We're going to fill it up for both players. And I'm trying to structure this. So each player, we're going to start a flood fill from their current head position. We're going to copy the board, and we're going to flood fill from it. And then we're going to count the ones for each one. Okay, well, we have to clone the board. Mut test board equals state.board.clone. I hope this works. We just call it clone. And what we want to do now is we want to write a fill function. Fill test board with state.heads. And actually that's not correct. Because we want to start at location here, not at heads. So let's do it the slow way first, then we'll find the way after. Heads equals state.heads.clone. Heads state.player ID equals location. And then we're also going to do testboard.set location to be state.player ID. And this is where our 1 comes from, because we have at least the 1 score. Because before we came into score lock, we verified it was a valid position. And we're going to fill it with not state heads, but with the new head structure. And this will probably be a reference, and this will probably be a board. It's going to be a mutable board, not immutable heads. Then we're going to have to count the scores, but let's worry about the filling it first. Filling is a kind of tricky algorithm, and it involves a lot of keeping track. When you do the very slow approach first, is every time you have a valid position, we just check. We push it on a list, and we keep iterating through the list. So, function fill. We have a board, which is a board matrix. No, it's not a board matrix. It is. No. It's no longer a board matrix. We need a different matrix now. We need one to track actually which players at each color. So it's going to have two values. It's going to have a distance and a value. So we're going to need to have a second board. And I'm just wondering how we initialize this board. Actually, you know what? We can actually just send two boards in. We have the original board. We'll do that, and we can actually send in a board that tracks the minimum value. It seems probably inefficient, but I don't know. The distance board is going to be not clone. How did I create an empty board? Whatever, we're going to do a matrix I32 new state.board.width state.board.height. Will this actually work? I think so. I don't know if it's the best approach. I'm going to do the two boards. I was actually thinking of doing a... Shit, no, I'm going to do this the correct way. We need to actually have a duplicate board. Because the logic gets really hard, and I don't want to have two boards because the logic starts getting very difficult. So I'm going to have a path board, a path cell, and a path cell is going to have a. This is where it gets really. The path cell is going to have a distance. The closest distance to it, and for which player controls it. And I think this is enough. This should be enough, and I prefer to have it stuck together because I think it's easier to deal with. I just don't know. But then we have to deal with the cloning, so it's going to be inefficient. Now, let's just do it the other way. Let's do two boards. Fill. Now we need, is there a way to get a maximum int value? Max I32. We could also do this, state.board.width times state.board.height. I think I'm just going to do it the two boards now instead, because otherwise I had to copy it around. So standard max, that's good. And we'll see how this works. So we have the board that takes the players, and we're going to say player board, and dist board. And we're just going to fill in from the heads. So we have the heads here, and the distance is how far it gets from each of them. And I'm going to start writing this then. Fill, actually, let's maximize this. So guys, this is going to be a little bit slow here. because these filling algorithms take a lot of sort of work. And so we have, not matrix I32, whatever, doesn't matter. So we have a playboard. Playboard is an AND mut board matrix, and a dist board is an AND mut matrix I32. It's the same, but we're probably going to change it later because this playboard is going to be smaller. And the heads are and vector 0.2. And this is where we simply say, the first thing we do is initialize the playboard. Playboard.set for each head for I in 0 heads. Set heads I to I. Dist board set heads I to 0. So the distance to this initial position is 0, and we do that for all the heads. And this is our seed location. What we also need is seed at this point. So we're going to track all the open seeds. And we're going to have an open vector. This is usually typically called open. So we have let mut open. Okay, that makes sense. I32. No, not I32, 0.32, 0.2. You mean that, right? And 0.2. Is there a linked list type? Rust linked list? Or is there a deck type? With own nodes. Deck. Do we have a deck? I want a deck here, actually. VecDeck. VecDeck sounds good. VecDeck. Push front, push back, and push front. I'm going to assume both of these are very efficient, and that's exactly what I want. We want a VecDeck. Open is a VecDeck. And this I'm not sure yet. We need to have a position, and so we need to have a 0.2, the player's position, and an I32 for the player. So what we have is the open deck. These are all the places we have to consider still. Do we actually have something there? Can we play it? And trying to think, instead of initializing it this way, yes, that's what I'm hoping. Deck, that's what I'm hoping, is double-ended queue, where both pushing to the front and to the back is efficient, and popping from the front and back is efficient. That's what we need here, and we'll see why in a little bit. And it's the init step is always the pain in the ass to get the init precisely correct. And so we have the distance. Maybe we have a distance here as well. Let's put a distance as well. This one's distance. I'm not liking this anymore. Now I want a structure here. Can I have local structures? Location is a 0.2. I'm going to assume I can. Distance is an I32. And player is an I32. I need to do this? You sure? That's weird. It works differently than a vector? It shows VecDeck new here. Or do you mean I have to do that? Do I have to do it this way? Vec open equals vec dec new. Something like that. Okay, so we have a local struct, we have open. And in the heads, we're just going to initialize this. Okay, we'll see what happens. So in the heads, we want to initialize the open structure. So open.push the turbo fish. What? Sorry. What is a turbo fish? I don't know how to have a turbo fish. And we're going to do an open here. Lock is going to be heads I. Distance is going to be 0, and player is going to be I. And then we do a while loop. While open. I forgot the colon. Is there an isEmpty function? Empty is empty. And for all of these things, we're just going to loop through until it's not empty. And for each location, we're going to pop something off the top. So let op equals open.pop front, because these will be the lowest locations. These are the ones with the lowest value. Okay, so now for this location, we're going to check. We know these are all valid. These are all going to be valid locations, but we don't know if the distance is any better. Let current distance equal distanceboard.get op.location. If op.distance is less than current distance, actually, rather than if op.distance is greater than or equal to current distance, then we continue. We're done. We don't put the player here. Well, let's sum up equal pop front. That looks cool. That looks much better. There's nothing here. If we do have that distance, it means we claim this cell. So the playboard.set op.location becomes the player. Op.player. We now own that position. And the distanceboard.set op.location becomes op.distance. We claim the position and we put an open position, and now we're going to check all the positions around it to see if there's any of them that are open or any that are free. Okay, so we have the same thing now for next direction. We're going to do it basically like this. Now for each possible direction, we're going to check in the most inefficient possible way. We have op.lock.stepd. If the board is free, and this is the play board. If the board is not free, we continue. We don't have something free. We could check the distance right now, but I'm just going to do the loop. I don't want to duplicate this check, so I'm just going to add it to the list. So next distance will be op.distance plus 1. So we have to step 1 to the next distance. And so now we're going to say, now we have to check what our next step is. So we're going to say next op equals open. Location is next distance. No, location is NP. Distance equals next distance. and player equals op.player. Now, if open dot is empty, doesn't matter where we stick this thing, open dot push back next op. And else open dot push front next op. This is bad. I want to say and if it's empty, or can I peek at the front one? I want peek. Peek. Let's check vecdec. Do I have a peek function? Peek. Do I have a front function? I have a front function. Front. Front. And I'm sure there's a map showing. Functional update syntax. Yeah, I am interested. Or open.front.unwrap dot distance is less than next op dot distance. So what I'm doing here in this vector is oh, so that's the one player then. Now, I kind of like the explicit bit because I'm going to have the same names duplicated a lot. I know that syntax there, but I'm going to have a distance inside here and a distance out here, and I'm going to have a new distance, so I'm okay with the explicit right now. And so this .op syntax is going to save us the one player field, but hey, why not? Let's just do it. It makes it explicit that we're copying. Okay, so back to this open vector. If it's empty, we push to the back, or if the front one has a lower distance than us, we push to the back as well. Otherwise, we push to the front. What this means is we evaluate all the lowest value items first. The lowest value items become comma dot dot. Oh yeah, okay. Does it have to be comma dot dot, or is it comma space dot dot? Well, I'll just be very strict on that. And we go through this and we fill it all up. And this means we're going to slowly alternate between the players filling up the board. And this should eventually end as the board fills up. And because this is online in a browser, this is going to be amazingly hard to debug this if our logic is wrong. It's going to be very hard to visualize what's happening in here. When I did this before, I did it offline, and I had a little graphics program that would output each step, what you're doing, and okay. And a priority heap, yes. This is a priority heap, except I'm taking advantage of one thing. A priority heap has a very high cost for its insertion. And what we're doing here is our actual insertion cost here is constant. We don't care how much is in here. We either stick to the back or stick to the front because our values are always going to be in the correct place. And this actually saves us quite a bit. And there's a lot of hand waving I can do right now to justify why this is. But since we always go through an order and our distance always goes up by 1, this will work out that way to be constant. If your heuristic, this is your heuristic here, right? If your heuristic is not just +1, if you actually had a function, then yes, you need to use a priority heap, and that slows it down. But a priority heap is the correct way to go in general pathfinding. Not necessarily flood fill, but in pathfinding, and we're actually doing pathfinding here, we're actually just doing global pathfinding for every single position at once, which is kind of like a flood fill. Flood fill and pathfinding are very similar. Okay, so let's hope this works. Now we need a second one. We need to actually count the pieces. So how do we actually do that? We want to count scores, and our playboard now is actually filled where possible with the player number, the player ID of things that are filled, or it's going to be an empty cell. It'll be a player ID or empty cell. We discard the distance board. That was temporary. scores equal. Okay. And now we have to calculate the scores as well. Count scores, and this is going to be a play board and board matrix. And this is going to return a vector of I32. I don't know how to do this. Let's just do scores. Vector I32 is vector new. I want to initialize this again. Actually, I need an initialization of the number of players. Num players. And we're just going to assume this is right. This is an I32. What was that thing again? I need to fill a vector of length num players with zeros. I think you mentioned that before, right, source. So and now we can actually just go through. I'm going to put a different value on this matrix. Linear len and self is an I32. X0 len. Let's go back. Okay. Vec 0, comma num players. Okay, we start them all at 0. And now I want a linear length of this thing, and we might as well make this a U size now because we're going to use it as a U size. And actually, I'll do an 8th I32 for consistency. Everything is consistent here. Return self.width times self.height. Linear get is going to take an and self and a location, and it's going to be an I32, and it's going to return a t. And we'll just assume the right value. We'll let it panic if it's wrong. Self.cells location. Okay, linear get. This lets us walk through in a linear fashion. Because when we're counting the scores, I don't know if I can do bookmarks or anything in this editor. It gets kind of annoying. But what I am going to do is, because I haven't submitted in a while, I'm going to start copying this over here. We have compete, and we're going to do Tron. Okay, and I don't know where I am. Score log, score logs, count scores, count scores. For I in 0 dot playboard dot linear len. I hope it calls this only once, not that it calls it every time. Let player equal playboard dot linear get I. P is greater than or equals 0 and P is less than num players. Scores P plus equals 1. Scores. Okay. Now the question is here, and this is going to be a strategy choice. Do we return our score or do we return our score minus opponent's score? Because we actually prefer positions that not only have our score being higher, but have the opponent's score being lower. So we should probably do it that way. And we'll try both. Let's try the first one. Let's just say let's mute our score equal scores. Yeah, you're correct. P. So we don't even need this score here. Ooh, wait, no. Shit. Yeah, we had to change this. This clone here it has to replace all the player ones with an impassable value that just says blah, you're filled. We'll get back to there. Set blocked cells. And this score goes away, actually. I'll explain about understanding this when our score is equal to state.player_id for I in 0 ... state . Do we have enough players in the state? Just do heads. So these are all the players. If I does not equal state.player_id, our score minus equals scores I. And then we're going to return our score. Except we don't want to calculate the squares we already had. Those all have to be blocked. So when we do the clone of this board here, I think we made a mistake there. Whatever, we might have set this one twice. We're going to have to double check this, but okay. When we do this clone here, the board's set. Just before the clone, we want to do a replace board. Do a block board. Let's call it this. And mut playboard. And this is going to replace all the cells in the board that have a player with just a blocked value. Minus 2, I32. Block board, and we're going to say the board it's a mut board. And we do a linear thing again. If P is greater than or equal to 0, means it has a player, then playboard.linear set I, block cell. The reason I'm doing this is because we don't count the existing lines for the player. We only evaluate future value because there's no points in how many spaces you have covered. You just got you only survive if you win, so we want to make sure we have the maximum free space left. So I'm hoping these become all really, really tight loops in Rust. And there are ways to optimize this, but we can worry about that later. So we block the board, we do that. And we need a linear set. Linear set and self lock I32. V is a T. Self.cells lock equals V. Alright, so now I'm going to go out of this view, and we're actually going to try and compile this and see how many errors we have. And I'll just assume we have errors. Right, and I think that's what you were saying before. 172. Alright, I don't understand why I need that syntax, but okay. And 216 is what's the problem? Okay, we're going to have to include the standard deck, what? This is really just a very straightforward compiling part. Do you mean matrix 172? I did 172, 197. Alright, let's try that again, because I think I got confused by those two. 190. Again, for people joining us the very first time, I manually scroll down because there's an error encoding game that if I click on the button, it doesn't actually go down to that position, it just jumps me to the top of the file, which is, as you can imagine, not very helpful. 233, that's fine. use direction start. 177 looks like a confusing one. Count scores. Standard marker size is not satisfied. Aha. I-32 does not have a constant size. Okay, so how do I do that? Do I actually have to return a vector? Well, for now I'll just do it this way. Count scores. And this will return a vector until somebody says otherwise. Wait. Why can't I do that? Why can't I return a vec I-32? Or do I have to take a borrow it? Do I have to borrow it here? Borrow. Let's see. Let's see if that works. And the rest looks to all be related to that. Okay, so that's what he confirmed. So we want to return a slice here. We want to return a reference. Can I turn a reference to a local, though? That seems a bit weird. I want to turn a copy. I don't know yet. We're going to find that. I think it was compiling there. We'll see. Okay. Deny warning is what it is. Yeah. (226). Yes, I want to return that. Scores. I want to return scores. (641). What does line 41 have a problem with? That's use size. That's use size. (179). As use size. Okay. Okay, lots of errors still. We compiled quite a bit. We did a lot, so we can probably get there. Head state is not 170. What's the problem here? 170. Head state player ID as use size. Count scores. Count scores is up here, and it has state.heads.len. And we might as well make that a use size because that's what it's going to get. Misdutch types, A is not equal player ID. That is in 191. It's not in 191, it's in 181. As use size. Linear gens, linear get. You mean on this line like this? This also needs a... Oh, that's what you meant, okay. Expected slice found struct. Wonderful. Yeah, I got it. Good. Thanks. 220. We lost the place for I and heads dot len. Oh, come on. I don't even know what that means. No method found. Linear gen for type. Linear get. I didn't want linear gen. Linear get. Linear get. Can't make it any smaller. 198 has something whiny about us. 198. I'll ignore that for now. 203. Num players. That's I32. Count scores. 221. What do we do here? 221. Open dot. Push back. Doesn't matter. These little things that have dynamic allocations, when we get to the higher games, we're going to look first at these things because they might be costly. I don't know about Rust's Memory Manager. They might not be costly either. Ah, we're getting down here. 204. Scores. P as use size. Found I32, found U size. I32. 199. What do we have now? 199. Yeah, okay, so our VO should be fine there. It's not the value copying I'm worried about. The value is small. It's the actual, and if there's any dynamic memory. I don't know what the error is here. Expected I32 found U size. Why would a vector size be expecting I32? That doesn't make any sense. Yeah, which one's the len though? That's what I'm really confused about. Aha, okay. That would be the issue. .44. Yeah, this has to be a mutt self. 173. Mutt board. Yeah, okay. That makes sense. We had the wrong one. We're creating the wrong elements here. Okay, we got that. Looks like it's compiling. And we died. We died. No, we died. Something's wrong. We have to find out what. Alright, so we have the score location. So when we take the next counter, the wherever our next direction is, we're going to show the score for each one. Print line. Position, score, and P, comma, score. Let's see what we get out of this thing. I don't understand that. Come on, where was that? Okay, so we said, did we start right together? We did, that was stupid. Should have pointed the direction too. 0,6 gave us a really low score. It's right here, and 0,8 gave us a better score. The delay, yeah, it's... Oh, we won! Oh, okay, that's that. We won that time. That's why we didn't get any outputs. Alright. We lost. We should probably output what player we are. Ah, second. So we'll be player 1 then. So we have a whole bunch of negative scores, and this one makes sense. And it makes sense because he's winning, which means his best score at -1 here is bad. There's going to be none. We don't have a best score. The block cells won't count because the block cells don't match the player ID. That's why I blocked them. So I don't add their cells. That's why we block them out, they go away. But it has to do with the fact we're getting all the negatives and the best score is starting -1, so we're just totally messing with this. So if score is none, or score is better than best score, score equals some score. I think that should solve that one there. Yeah, okay, 263. Best score is going to be an option I-32. Yeah, sure, why not? That makes more sense. That makes it easier. We're actually doing something this time. So we totally cut him off that time. We may have gotten lucky, so let's try it again. I want to see one of them work. Yeah, we totally blocked him off that time. So I think we got it right. At least we didn't screw up, so let's submit that. And see how well we do. Every single one except one we lost, there is some guy that actually did it better. But this is looking like a good output. Uh-oh. Yeah, okay, that looks fine. Well, let's watch some of them. Let's see what some of them are doing just to see for fun for a bit. So we're orange this time. That looks good. We're orange again. Oh no, we're pink. I was going to say that looked like a really bad... what did he do? Oh, he screwed up. Sketchy screwed up. So we're red. And it looks like we're tracking him pretty good. That looks good. It looks like we're doing pretty good. Yeah, we're cutting him off, which is exactly what we want. This looks a bit suspicious now, what we did. But we're not looking in the future. That's one thing you have to consider, is we're not looking in the future. And we've managed to cut him off there. So we look just the one step forward. We have no ability to look in the future. That's what we'll have to do in the advanced versions. But we still beat him, even though we made what I think a horrible mistake there in the game. We should have gone down over here on that one. You can't see where my finger is, but sorry. We're doing quite well. Uh-oh. Wow, we did something stupid there. We made a mistake. That was bad. Alright, who wins this one? This is a bit of a race. Who has more cells available? So if anybody's... Oh, he made a mistake. He's not doing the basic algorithm, because right at the end there, you should be able to tell when you're stepping on the end, your flood fill will tell you that you've basically cut it off and you screwed up. I think we're doing just fine, though. No, sorry, I can't. Yeah, looks good. Yeah, sorry, I couldn't see that whole screen. The reason this wraps like this is because every time you take a step, it's going to follow the line closely, because the flood fill is really watching. It's a really decent algorithm for filling. It's taking the closest one, and so little minor adjustments actually make a huge difference. And we're at number 1 already, and we have a long way to go, I think. And so this scoring mechanism does really well. Flood fill does really well here. And our score is just killing Boss Quora. So we should have no problem finishing this Wood League. Up to 32. Like, this is a huge lead. But yeah, flood filling this way, it makes a lot of sense. And it's just a matter of speed. If we can respawn fast enough, maybe that one time we died, we didn't respawn fast enough. And we might have to optimize this. But we have, like I say, we have a really good lead. And we still have several. We're at 73%. And I think we're just going to submit in the next round right away to see how well we do on the leaderboard there. I don't know how far in the future we have to look. The one thing that's going to come up is that right now, as I say, I don't predict where the enemy's going. I don't do anything of that. All I do is I check our next step. Where do we go? And I'm so happy the code was actually correct the first time, because this is a pain to debug here. And so the next one, what we're going to actually have to do is, instead of valuing all 3, we're going to compare, see what the other opponent does as well, because that one little position that the opponent might do could be quite significant. And maybe we walked into each other in that one. I don't know. I don't know what happens if we walk into each other. We probably both die. And so what we could do is just start looking further into the future and just get 4 or 5 steps ahead. But this becomes too much space to cover. But if our algorithm is really fast, and if this works, if Rust is compiling here, hopefully in an optimized mode, we can actually get away with doing thousands of these evaluations. No, that means the actual time, 1:23. That's 1 minute from now. So we never wait for very long. Alright, so we got promoted. We did just fine there. We'll be promoted to the Bronze League soon. Have we been promoted? Come on, come on. We've been promoted. Alright. We might as well Twitter this. This is fun. Okay. And... yes. Alright, so we're just going to submit this again and see how we do. I wasn't expecting to do that well on the... What league are we in? Oh, we were still in the Wood League, so... Let's see what we're doing. I can't see chat again for a bit. Oh, no, 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 no. Okay. Yeah, we won this one. We can still get trapped here. Our algorithm, because we only do one step in the future, we can trap. That will never get trapped. In this section here, we'll never get trapped because we step here and we realize the score drops to 0 immediately. And here it's still open up, but there will be 0. And he got trapped before us. And that should be good. We're red this time. Okay, I think we pretty much won that one. Shit. We make an error. What is that error? We're going to have to figure out what that error is there, because that's more like a fundamental mistake. I don't think it's like a calculation error. We just emit something wrong. Because we were winning those ones. And then we did something stupid. Again, we did something stupid. That's not good. Those ones are failing and we don't know why. Yeah, but no, because the last one, we would have had to gone right instead of left. Like, one of our directions is somehow wrong, and we're not checking validity correctly. Something went wrong here. But our ranking's still number 1 anyways. Into their tail or into their head? Into their head. Yeah, that's the one thing I said we don't take into account. We're not taking into account their movement. Alright, hello. I have a feeling I turn into their head. And we're going to have to look at the rules very specifically. I do blow up their initial square. They say that we only start in a single point. We don't start somewhere else. The opponent's move. What happens if we both go to the same place? This is my biggest question. I think it's because we're going to the same place. I've chosen a spot that wasn't filled, and then we both go there. And yes, that's the importance of the ordering. That's why we have to consider the ordering of the players, because he's going to do his move first. Moves are done in order, aren't they? So I'm guessing this is, I think the moves are done in order, and that would explain why we lose these ones. So what we have to do is we have to consider if we're beside his head and we're not first, you sure it was their head or their initial thing? Let's look again. Okay, well, we have a few tweaks. We have a few ideas. So we're either crashing their head. I screw up their initial position. Or I screw up the ordering. I think those are the two cases there. They're both bad. Let's see what happens. Oh god, we do actually win this thing? We should. Yeah, we do. We're still doing quite well. We're number 1 here. Let's see where the leaderboard actually is. We're still winning by a long shot. So I still think we're going to hit the next league, nonetheless. And even with these defects, and I think these are 2 simple defects, which gives us a good chance that a simple defect would actually Having a simple defect would let us basically fill in the... Sorry, I mean, it would probably let us get even further. Who is Stone43? Are you watching as well? Can I actually click on you? Am I your friend? I can't get to your profile. So, we'll assume you're a friend. Yeah. Okay, you guys, fine, we'll check it again, but nonetheless, even with the defects, we're doing just fine. Right? We're doing just fine with the defects. There we go. Come on, we'll follow you. That's how we did it. Thanks. Thanks, Incoin. We follow them. So I think if we fix the defects, we'll get even further. That's what we can watch. It doesn't matter. We'll see. What? Really? No. Come on. 0224. Why do I have to wait so long? Well, that's no fun. Why am I waiting so long? Yes, that's an hour away, Rhyosaur. Really? Nice picture. Okay, so we're waiting to be promoted. We can fix the defect in the meantime. We have 2 defects to confirm. We have the ordering defect. And we have the heads defect. So, the scanning, we have that. Well, we do it amazingly well from a very simple algorithm. We're doing quite well. And let's see what we can do to fix this stuff first. Maybe we can do even better. Or do we risk it? Do we get risk screwing up? Yeah, that's what I'm going to try and do. Where is my scanning? Let's fix that first. Starting x coordinates, or -1. See, we totally ignore the starting coordinates. And this is what I'm really wondering about. Let's check the description again. Look, the first starting coordinates are exactly the same. So I don't think it's the head to tail. I think we do this just fine. We set their tail, we get these 2 positions. If this is what the input looks like, we're setting it fine. I think it's more a matter of we should just completely avoid the head of them. That is, we've lost a few. Can we actually look at the battle charts? Did we always lose by hitting their head? Who are we here? Shit, so we hit... So you guys are right in that one. We hit their initial tail. Why is that? Why on earth is that? Yeah, that's the one I clearly saw. I dived into their initial position. But why would that be? What am I missing? How am I missing that here? It has this copy to IDE option. So we lost this one. I don't know what that means, but yeah. All right. Okay, let's see what we get. Oh, sorry, debug log is also from a different language entirely. Eprintln. And we're going to put the player tail, so we know what this is. Tail of player P. Tail. Yeah, that's what I'm just going to do for all of them. We can see from the game board where we get that back. No, it's giving us different conditions. That's not what I want. Bastards. I press the same button. Where is this? This is annoying me in this editor. I gotta go back and get it again. Just remind me not to press this button. We have to press this one. Okay, so we lose. We don't have to see this. Go right to the top. What do we get out here? Tail 1 is 24,0. Huh? Okay. That looks correct. We have the initial board set up correctly. Right? Wait a second. Yeah, replace it. How close is match? Are we missing the bottom one? What do I do this? Read step, state, dump. I read it and then dump. So we start at 0, then we dump. 14, 17. We have one position. But you notice our 0 is not the same as theirs. (14, 17). I have a feeling it's lying to us about something. I really wish... Yeah, I'm going to print the initial position now. Because I have a feeling that it's starting at a different initial position. And it has to do with the fact that we do stepping and ordering, that we're not seeing that first initial position. Alright, let's check this out. That's what I want to see. The delay on Twitch is kind of annoying. I can fix stuff before your response. Alright, check it out right here. This is why we get the initial position. And this confirms something about the game. is we're not playing simultaneous turns. We play his turn, then my turn, then his turn, then my turn, then his turn, then my turn. And in this is the case, we have this one position. It's for this very first move is why we have this init position, is because they might have had a turn already. So if init.0 does not equal -1 and init.1 does not equal -1, then we have to self.board.set init comma p. And that'll take that, and let's see what happens now when we replay that one. This jitters so badly. Alright, that looks better. And we probably beat him here. Yeah, we're just going to go around in the circle here. And we clearly have more space than him. So let's resubmit this with that defect fixed. And that means we don't have to worry about my defect where I said, do we have to worry where he goes next? Because it looks like the game is played in an order of turns. He goes and I go. So it's not simultaneous. And so they avoid defects that way. They avoid problems that way. It's just simply not simultaneous. And he's run out of space. And we have lots. We should stop right about here. And because our algorithm, as soon as we get here, we've cut off the section, so we should be okay. No, it's definitely to do with the ordering, and that's what this confirms. It's not, they don't have variable length snakes. It's not saying like you draw a line. It's because of exactly in this case, if you saw what happened on my first turn, look, he played up before I even got a turn. Right? He plays up, and then I get my turn. And that's why he has 2 points. He's done his turn first. Alright, so we're going to clear that out there, because this ePrint stuff here is really slow. Clear that out. What do we have? ePrint. We have no more ePrints. It's a bit weird. I thought we had one in the scanning. Alright, let's submit this. Let's play it once more. Let's see if we get a higher score. What was our score last time? We were at 36. Let's see if we can get higher than that. Well, this is an interesting one. I have no idea if we're going to win this one. Oh yeah, he made a mistake. I think. Yeah, it made a mistake. Now, we should have actually gone here, which means it's ambiguous. We screwed up. And this is exactly the one we can't look in the future. I think we made a mistake there, but oh well. Let's see what happens if we... I don't care. Let's submit it. Let's see if we do better. We lost one. Hey, we better check that one out after. So we're back down at the bottom. It resets us when we submit something new. We don't know if we'll do better. So there are some that still beat us. It doesn't. Maybe it could be us making mistakes still. And we don't always have the same color here. So don't always assume we've lost when it disappears. We got up to 6 really fast. Like that was really fast to jump up to 6. And we're at 2. Alright, we're doing amazingly well now. So that variable fix probably fixes a few. Yeah. That might have fixed a few of them. Yeah, we're doing well. Yeah, we're in first place already. And yeah, we're doing a lot better. So we ran into their first line a lot. Battle's 11%. And okay, so let's find one of the ones we broke. Knowing this game goes stepwise actually simplifies our logic. That is, when he goes first and I go first, it simplifies some of the cases I have to deal with. And that's really actually helpful. It's something we could have dealt with anyways, but I'd really like to see multiple players. How we do with 3 players, we've already accounted for that. We already have, like if we take 3 players, we already have in the scoreboards, score location, we already account for 3 players, and our scoring function, wherever this is, right here, we already take into account the other players. So there's multiple players we already take into account, but what I don't know is if we completely break when one player disappears. I hope not. Yeah, crap, we're going to fail, because when a player dies, their path goes away, but we don't clear it. So the moment we add a 3rd player, we're going to fail. But that's a simple fix, I think. I don't know if we can get to 40. I don't know what this value is actually memorizing. But I don't want to fix the 3-player case until I have 3 players, because I want to see what it looks like, because I don't actually know what the input looks like anymore. If a player, I don't know what indicates that they died. We do be getting quite a bit here. That's really good. Anything else we have? Evening Smurf. Who's a Smurf? I don't know who's a Smurf. Alright, so we're still going up. So let's check one of the ones we actually lost. Or actually, let's... I'll let it run, and I'm going to take a quick break. You guys can watch that. Now I'm going to take a quick break, and I'll be right back. Figure out why I'm losing. Alright, we're still watching. I just forgot to fill up my water. I'll still be right back. Alright, I am back. Yeah, that's actually true. All games are played with switches. Okay, so that would mean we tie sometimes, and that might be the reasons why we flip back and forth. So you can't win everything. You have the possibility if it's flip back and forth, you tie then, which seems fair. That seems like totally reasonable, and that may or may not be the reason why we're losing. What is my score up to now? 39. Can we get to 40? But surely, I guess this probably means nobody implemented actually any forward-thinking ones in this league. So the Bronze League doesn't look to have any bots that look more than one step in the future. And our one-step looking, we appear to have the only correct scoring function. I'm trying to check here. There's icons we can't tell. A lot of these guys don't have icons, so we just win. Let's check these two. And we can't see who it was. Evening Rust versus W Mage. We lost, and then we had a win. No, we won, and then we had a loss. W Mage, and we had a loss. Were those the opposite starting points? No, we just did something stupid. Guys, we just made the wrong decision there. Did you see that one? That was just a mistake. We're red. I think it's a win or lose, but look at what red does. We're red here. Yeah. And that's because we don't look forward. Alright? We got cut off because we look one step forward. And it was right at... Oh, and this stepping back clearly shows that we have multiple players. So right at this point here, and show this what happened here. So much for full screen. Right at this point here, our algorithm actually says if we go here, we'll have more space, but we're not accounting for the fact of him going here. So when we step one, you can, okay, let's go back. So we go here, we step here because this is our best choice, assuming he doesn't move. But then obviously he moves here and it cuts us off. So this also means if we look one in the future, we would beat him. But that's what I mean, we have no future looking right now. We have absolutely no mechanism that prevents exactly this loss right here. It's not clear that he actually looked in the future. He just took his optimal thing. We would have done the exact same thing here, except we wouldn't have turned this way. And so that's the thing we're going to have to fix the next league, is we're actually going to have to look in the future. And that means just stepping more in the future and deciding what's going to happen and predicting what he does as well, the opponents. Alright, but we're doing... Oh, come on, we're not going to reach... We didn't reach 40. No 40. Sorry, we're just not going to reach 40. And we're actually using a minimax algorithm right now. We're just only doing one step in the future and ignoring them. Right? This is effectively what this does right here. This part right here where we subtract their scores, this is going to be the minimax basis of our algorithm, because what we're doing is we're taking their scores away from ours. So basically we're going to reduce it. If we see any possibility for them to get more points, we're going to avoid that as well. And it's hard to call it minimax though when we only look one step in the future and we don't consider them, but technically that's this part right here. We do consider what they do and we do try to minimize it. But we're going to actually have to step them into the future, and that's just going to be a few more steps. I'm not going to do it today, but it's going to be a few more steps of saying whether we go, how many steps, and we're going to have to sample those steps because we can't split it out. But it depends how fast our rust is. If we stop outputting stuff and we make the rust a lot faster, we could probably get through like steps down to a depth of 8. How long do we have to actually do? How long do we have? Wow, 100 milliseconds. That's a lot of time. I don't know what computers they have back there, but 100 milliseconds lets us evaluate thousands of tests. And the issue with Minimax is that it expands in a tree, because for every one of my steps I have to anticipate the next player's steps as well. and backtrack. So even though we can do thousands, we're going to have to really trim that. And we're going to have to find a few other options to say, what can we do? What we might want to do instead is we might actually consider a danger area. So the one case where we won, where the guy was right beside the head, we might actually say that everything beside an enemy's head is a danger area, and we should avoid it, because it puts us in grave danger to actually walk inside their danger area. And so we can actually put that in the score as well. We say, if you're in the danger area, look out, we're in trouble. And or if we have a danger area we can't get out of. And that would allow it to, that would give us a good boost without having to go good depth. Really far depth would do the exact same thing. Without looking more in the future, let's look at one of the ones you lost. Let's see if there's anything else we could possibly fix on here in the losing ones. But like we've won almost all of them. Alright, this one we lost. So we're red. And we did something weird. What on earth did we do? We took the wrong direction here. And this was probably ambiguous. Let's pause this and go back. And try to understand why we took the wrong direction. Okay, so right here, we go this way, we go to the left. Well, it would have made more sense to go to the right. But actually, so far, it may not make a difference, because so far, it may be the exact same area that we can cover in both cases. But then where did we go actually wrong? What point did we actually go wrong? We start cutting it off here. And there. There we make a horrible flaw. We must have a defect around here, because there's no way that doing that left move here this move from here to there is a horrible flaw. And I know exactly why. This is a limitation of the flood fill. We actually have to change the flood fill algorithm. Because when we're here, I'm filling on both sides, and I'm counting both sides. And actually it doesn't make a difference. Because if I'm here, filling this is going to go around here, or around here. So yeah, we're limited. We also don't count the split. Assume this was covered here. Our flood fill also wouldn't count the fact that we split this in half by going here, because it would see, the flood fill would see that we could go both directions. And so we actually score it wrong there as well. So we're technically scoring that. It's not the ideal position, even not considering the opponents. So we have a few actual scoring issues to fix. But that should be something we can fix afterwards as well. I don't want to fix it in this one. I'd really like just get the next one. I don't know if I'm going to wait that long. We unfortunately didn't make 40. Let's go do some random contests. Actually, let's copy this code out before it's lost forever. Tron. And let's go play one of the simple games maybe. And I just really like to see us get to, it's a long time though, or should I call it a day? I really want to see how we do in that next league. So I'm going to wait. I'm going to go back. And hey, back. Go back. Alright, back is broken. We want to do a Clash of Code. We got quite high in the ranking here for selling simple games. Let's just join a clash. Let's knock my cheer back down. And we'll distract people again. Flashing live on. Coming down from a Tron high. Woo! And we'll see what happens here. Okay, so we identified a few algorithms. Other than going a future in the depth 2 steps, actually no, that's splitting. If I actually went 2 steps in the future, the splitting would actually be solved as well, because that automatically solves the fact that it split it in half, so I don't have to worry about that. It might anticipate the other player as well. So I think simply stepping 2 steps in the future is good enough. But we have to anticipate what the other opponent does. What we could do is, I just say, it's the min-max strategy is, instead of anticipating what their best move is. Yeah, right, so we're just waiting. We're waiting for the time to pause out. It's 24 minutes left to see if we actually get to the next league, and I want to see it work in the next league. And we didn't quite hit 40, we hit 29.14, I think, or no, 39.14. And I saw a few issues that we could improve, but they would both also be just improved simply by having a time step. But as to the minimax, I don't think we have to get the other player's best player. Thinking in terms of that, we can probably just choose their move that goes closest towards us. And that impinges us the most. If we just assume the other players are chasing us, that probably helps the minimax strategy the most. And so we have encoding here joining us. And we're going to see. I'm all out of energy, so there's a very low chance that I'll do speedy anyway. We'll see what happens. And all these other players advertise. People should upload some sort of avatar, or no, rather, coding game should give us a default avatar. But overall, regardless of what happens here, I'm quite happy with the code we have. Again, all we implemented was exactly what I said I'd implement right at the beginning. We managed to get through the first wood leagues without implementing it, just by implementing a Crocker proper path thing. And by doing the one phase look ahead, we got quite far, and we're doing quite well. And we'll see if we get further. I'm just waiting for the 24 minutes. Kill a bit of time here and see what happens. And I want to see how far we get in the Silver League. I don't think we'll actually make it past that league, because we make a lot of simple mistakes, because our algorithm isn't hard. Anybody could do our algorithm. And so I assume there's going to be ones like it just there, and we're going to fail 50% of the time then. And all we need is one slightly better than us to fail more than that. And now we're hoping for people to join in. Nkoyan, are you actually using PHP? Your avatar says PHP. You think I will? Okay. That's shocking. I mean, I would be very happy, but that would make me very happy, because we're doing so poorly in the other game, the water gathering game. So you're actually coding in PHP on here? Cool. Alright, so you probably don't like the golf competitions either, because I'm guessing PHP is not good for doing minimal code size. I recall it being somewhat verbose, or has it improved since the last? I haven't used it in a long time. Last I used PHP, it didn't have classes, so that tells you a lot. Alright, so somebody should be joining soon, and I want to see a reverse engineering one. I've never done a reverse engineering one. Beeping, you can probably hear the beeping. Lowest code size. Alright. Yeah, PHP was I did web for that as well. A string containing the problem statement with some typos. two space-separated numbers. First, the number of misspelled words. Words are different from promise statement. Secondly, the number of missing periods. I am not a good spieler. Sometimes I muck. Well, that's mean to give you a code size, and then I have to stick this thing in there. Wow. I'm going to have a hard time finishing this one. Okay. Constant goal is equals to this. Words, periods, okay. Alright, so this is going to be some rusting stuff. What I want to do is I want to split it up. How do I split something up based on a space? Shit, this is all I really want to do is I want to replace the periods. Count periods. Replace periods with space. Split into vec. Compare vecs. That's all we need to do, and we just had to figure out how to do this in Rust now, and this is not going to be easy. So we count the periods. How do we counting in Rust? Let's look at the string functions. We have stir functions, stir, 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 stir. Split white space would work, character indexes would work, split at, split at. So we don't have a count, which is going to kill us here. Yeah, well I have a split. Split at, split white space, split pattern. Oh, so much here to split. Split. Okay, well, I'm going to do a count first. Let's do it the slow way. Let's do a function count. We're going to have to do a replace first. Count S on string, I guess. I32. Count dot. Oh, there is a count. Alright, let's check out counts. Perfect. Let's go for that. G dots equal goal.characters.filter. We can clean this up afterwards, of course, so we don't have duplicate code. Dot count. Let idots equal sentence.characters.filter and c equals dot count. What do we have to output? Secondly, the number of missing periods. So the number of second periods is question, and then we're going to do g dots minus I dots. Now, how do we replace all the dots with nothing? How do we rip the dots out of the sentence? I want to get rid of them. How do I get rid of periods? Replace. S replace old new. That sounds good. Okay, let's just do that. Goal.replace. Whoa, what happened there? Replace. Dot with nothing. Just get rid of the dots. Sentence.replace dot with nothing. Okay, we have gwords equal goal.split. split white space. Split white space. Okay, split white space. Let I words equal... Oh, the time is so rough. We're just going to fail that split white space. Let mort-ora-y equals... Indeed, it is. For I in 0. We're going to assume these are the same length. Always contains 39 words. Dot. If G words I does not equal I words I W plus equals 1. We have a word wrong. And so the words that are wrong are W. Play test case. Get compile error. Expect to go. This has to be a string or something. Oh, okay. We'll make these all mutable after because we can save text. Cannot be named the same as a constant. Whatever, then I'll do seagull. Actually, I'm going to stick it down here because we don't care. Sentence. What do I have wrong? Come on, tell me it's wrong. Mismatch type. String, string. Can I just get rid of this let? Or this? Yeah. Why does it not have a length? Okay, split isn't returning an array. It returns a... But that's not my problem. My problem is how to return an iterator into a strength, into a... I need to convert the iterator to an array. Iter to array. Collect, 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 collect. I recall something called collect. What do I have now? The type of this value must be known in this context. G.words.lang. Success. Okay, we have 5 minutes to reduce the size of this. G dots, how many dots are in the initial array? 1, 2, 3. There's 3 dots in here, so we can replace this with 3. Okay, and we're going to reduce this even more. How can we reduce this more? Obviously, the simplest stuff. We have the parse input we can't get rid of. Print error we can get rid of. Parse input we can't get rid of very well. We have parse input still there. And we can probably remove it. We don't actually use parse input. Yeah, G dots 3 minus, we don't even need that at all. G dots. We can do the obvious, sentence becomes S. s, and send this becomes s.replace. And we can actually do this if we make it mutable in advance. Just make it mutable. Okay, we can shorten. What else can we shorten? We're just going to call goal G. Actually, we don't even need to do the replace. We can just get rid of the dots in goal, because we're not counting them anymore. So we don't even need to do the replace. That shortens it even more. G.split. Ah, yeah, you can see he said the exact same thing. We still have a lot of code here, so GW, let's make GW and IW. We don't have to do the ultimate N there. GW, IW, and GW. Doesn't save a lot. Trim. Now I'm hoping I don't have to strip all the white space. That's not going to save us much, so I'm just going to leave it here for now. Is there anything else we could simplify here? This collect. There must be a loop we can do the exact same thing for here. Or how we define a macro. We can define a macro twice. I don't know how to shorten that. And probably a way to simplify this. Print line. There's nothing obvious. We're going to say just replace I dots with D. That saves a little tiny bit. Okay, I'm going to see what this does. Does this actually do something? You mean this replaces the count entirely? G.split, Z.split, S.split, count. So let W equals this. And if we remove this, that looks great. If that works, I'd be so happy. We need a semicolon. Nope. Expected reference found tuple. Uh-oh. We want something here. Unless you have an answer fast, I can't do anything about it. Nope. What about that? I'm just guessing here. I'm going to have to submit the other code soon. Okay, thanks. Awesome Ryosaur, that saves us a lot. So we don't even need those ones. That's really short now. Oh, I'm running out of time. I'm going to submit this before I run out of time. I don't know what it does if I run out. Yeah, that delay really sucks for these competitions. It really sucks. We didn't do so bad this time, though, for Rust. Only because I guess we have a resident expert. I'll expect you to be here every day now for it. And so we'll see what these other guys come up with. And Koya, and I'm curious as to what you come up with in PHP. So that code confirms we have a lot of sort of functional type high order operations on sets in Rust that I have to learn. And I want to look at that again to see what we actually had. So the biggest part of that was that sentence. We couldn't really get rid of this. Not in this time. There might be compressions. And you fail. Yeah. Sorry about that. I don't know what we can use, but maybe then. And so we have a split space zip. I understand zip and split. Yes, good. Filter. Okay, perfect. I understand what this does. I'm going to copy this because I want to remember this one. I understand what it does, but I'm never going to come up with that syntax again on my own. And that's really interesting. Zipping. For people that don't know, zipping takes two lists and merges them together and creates a tuple of them. And then the filter takes to reference this tuple, and it says if A doesn't equal to B, then it returns a new set of them, which we don't actually care about, and then we just count how many are in that set. And to replace the comma and dot, this is just because we have to get rid of them. Our input sentence doesn't have them. Characters, we count the dots, that's fine. I don't know if there's a shorter way. There'll always be languages that are shorter, but of course this site doesn't have any of the Gulf languages. But there's a lot of overhead in Rust. Like there's a lot of let mut let we can't get rid of, and yeah, so that would actually make sense if we did this on a gist. But then there's also the overhead of me copying and pasting it to the code thing all the time. Oh, you mean my cheat sheet? This cheat sheet? That's actually a good idea. I'll think about that. This was mainly meant for me, but I can start going through that and putting it back there. I'll think about that. So was this one fun? Sure, I don't know what to say. These now they're going to be exciting. Difficulty? I think it was perfect for this type of test. Statement was clear. Test case relevancy, I really have no idea. I mean, let's say ideal. We passed it. And our time must be running out in the competition. So we have more points somewhere, I think. So let's go back to compete. Copy a buffer to a gist. Alright, I'll have to think of that. I'll look at that. You mean from Visual Code? Or from the screen here? Oh, maybe, okay. Where am I here? I'm already in this Tron bottle. 2 minutes. We have to wait 2 minutes. We have to kill time in 2 minutes. And where were we on the leaderboard? We're still stuck at the top, I bet. Nothing's going to get above us because our game is done. And we're going to be promoted in a couple of minutes. And that's the only reason I'm waiting is I want to see how we do on the next level. VS Code. Okay. I don't actually use VS Code, to be honest. I mean, I installed it just for Rust. Just for this here is the only thing. It's the only thing I use for it. You can see in my background here, I actually using Kate right now. And you guys disappeared over there. This is actually code from the Leaf compiler right now. I'm this fail throw here over here is my new air checking, and I'm working that Leaf right now. And so Kate is still been my main editor. It has lots of defects in it though, Kate, and so it's kind of been making me mad the last year. So Visual Code is better. I'll actually switch to that, and as soon as I can get my high contrast color scheme over to it. But I'll keep checking, and so I don't know anything else about it. That's the thing. So I don't know anything else about Visual Studio Code. And are we being promoted soon? 1 minute to kill soon. What else do we have here we can do? Come on. Let's check my profile. Let's see where we are. Level 10. No, I wanted to see the scores. Scores are gone now. So, and Koyan, you're in the Legend League here, I guess. So you're doing quite well in the Tron game. So this is our goal. We're going to try and get up to Nkoyan's level here in the Legend League and see how we do. Refresh to lower limit. No problem. I didn't say anything that important. I mean, I just say I use Kate, and I don't actually use Visual Studio much. I just something new for me. Kate has defects in it. I have to get rid of it. There's some really trivial defects, but it doesn't look like it's being actively maintained, because some of the trivial defects, people that would actively use it would notice it, and so I don't know about that one. Come on, let me go to the league. Just 1 minute. I don't want to start anything else. Promotion. We have promotion. Yay! Made it to the next league. Can have to have 3 players. Alright. We're going to see... Alright, so we could actually clear it. Let's see how we do without clearing it first. I highly doubt we'll do well without clearing it. By not clearing it, I mean we just leave the other people in the board the whole time when they die. And we're still doing okay. And the 3-player games were sucking. So anytime there's 3 players, we're doing something wrong. Yeah, I'm not going to clear deaths. This is all I'm doing for today. I just want to see how well we do with our exact current code. And I think clearing deaths is going to help a lot. But we're just going to see how we do with just the current one. And actually, where are we? We're not doing so well. Clearing shouldn't be hard. And we're going to have to do it, I guess. But this is going to be pretty much all for me today. Oh, we'll see what we go up with rank here. There's a lot of people in this league. And a lot more than the previous one. We have a few simple mistakes we can fix. So we're going to... The first thing I'll do next time, I don't know when I'm going to come on next. Sometime this week, not tomorrow. Usually not Monday, Tuesday, and Wednesday. I have other streams on those days. So on Monday and Wednesday I have a stream already. And that's for Fuse. You guys can feel free to tune into that and watch me code animations and user apps. And then so Thursday is the first day where I might get back to this one. And you can already see we're not doing so well. We've dropped down again. So we're going to fail here a lot. And let's just look at one where we're failing to understand why. Who are we? We're blue. Oh. Actually, it may not be the clearing that's the problem. I think it's looking in the future. So we had 2 options. We can either look in the future, or we can put a danger zone beside other ones. And... No, that's the same. That's Jake. So Yup Ferris is doing the N6. No, he's doing a. Did he do N64? He was doing a Virtual Boy editor, so a Virtual Boy editor, and we're both at Fuse. One ran at second. All right. Yeah. So Rhyosaur, we're the same company. He's doing the Virtual Boy and the other Rust stuff, and he was playing Earthbound today. And died without saving it. Alright, so why do we fail this one? This is curious. This looks good for us. What happens? We get trapped in a box, and the blue one has all that extra space. No. What do we do? What happened? Oh no, I know why we failed. Yeah, It's we have 2 negative ones. I can tell you exactly where we failed. Where is that stupid parsing? Right here, when we do set tail, we have negative ones. And this is causing an index error. I'm positive this is causing an index error so that we just fail as soon as somebody dies. And let's fix that one quickly. 1 and tail.1 does not equal -1. And we'll just ignore the other heads. Else self.heads.push. I don't know. Where should we push the other head? I don't know what's going to happen here if we clear the heads. Alright, let's just do something quick. Because I don't want to do this anymore today. Point. Let's just push something stupid. Stupid. Maybe I should play it once. So this was just an indexing error, because if we push this bad location on, we're going to crash and not do anything anymore. So our code will just crash. I'll just submit this. That may be the reason why, because as soon as somebody dies... No, it's not that we don't adjust the player count. It's really that we push a tail of -1 on here, and then we index into the matrix of -1, and we're going to access invalid memory location. So we're immediately dying the moment another player dies. So unless both other players die at the same time, we just can't win. We have no way of winning a third-player game. So that simple adjustment should let us win actually some games. We actually have a possibility now. And you actually see it now. We can actually win 3-player games. We couldn't do that before. So that makes a pretty big difference. We put a stupid value in here. And okay, yeah. So that helps a lot. And I won't make any more changes. We're just going to let it go like this. That should be enough to not make a stupid mistake. And so at least we have the chance of winning. Whoever's red here wins. Are we red? No, we're not red. We're not even in here anymore. We died. Let's watch a few and then see what happens. I hope it's only playing interesting ones. And then on Thursday or Friday when I get back, I'll implement the death one. And see how far that gets us, and then we'll implement the look ahead. But this looks good for us. Unless we do something stupid. Oh, good, we didn't do something stupid. Alright, this is a really tight race between us and yellow. Alright. We should win this one. And we do that little walking back and forth. Good, we actually won that one. Alright, so Peter Tsang has an error in his algorithm. He did something wacky. And this one, we actually made a mistake here somehow. And that's because we didn't clear the first guy's thing. We should have actually immediately started going the other direction. And we're wasting space here, and this is part of our algorithm. We're wasting a lot of space. And this I had to figure out, why did we waste this space here? We should have known to go here. Oh, it's because we don't do look ahead. At this moment, they're both the same. And we can actually adjust the algorithm so when we have tight corners like this, we can devalue those tight corners. We can actually use, with an A-star algorithm, we can devalue them so even if we can't look ahead, we can at least devalue them so they get less and less. And I got an alert for something. What did I get? And no, Sasha, I'm not doing any more today. I'm done. Yellow goofed. I don't think we're going up fast enough. We are, though. We're at 88. Alright, so I'm going to sit and watch this a little bit longer to see if we go up anymore. And I'm going to watch it up there. Let's launch into that also so we can see what's actually happening some more. And sorry, I can't see the chat when I actually have it. Even if I have it keeping above other windows, I cannot see the chat while this is full screen. It's very unfortunate. Blue, don't make a mistake. Oh, we made the mistake. We went the wrong way. Terrible, terrible, terrible. Oh, well, yeah. We would win now, except we still see a path here. So we're going to do that because we don't see that this has been erased. So that's going to help a lot. Erasing will certainly help a lot. Even without looking forward, simply erasing should help a lot. And we should be going down now soon, yeah. Alright, we didn't... Anticipating that yellow is going to get over here is going to be very, very difficult in the algorithm because you have to look really far ahead to see that. And I don't know why we didn't go one higher up. Again, we still have some issues because that killed us. Or wait, no, we're yellow. They keep changing the colors. So we did the right thing there, but poorly. So we're yellow again. Why did we do that? Okay, because we were playing it off. Now this is where you might actually have to take a chance. We could have just competed with blue and hoped that Cham screwed up, and which they did on their own. And which would have given us a far better chance of winning had we just ignored the red one. So we might have to have logic in there eventually to detect... Oh, well, maybe not, because on the, I guess in the Gold League, it's highly unlikely in the Gold League we have people making those. You could cast to the next wall ahead to save some. Yeah, we can do that. There's a lot of options we have. Optimization a bit. We're at rank 55. Are we actually going up? Should show us where we are here, but it never does. Anybody else doing Rust? Oh, lots of people doing Rust. Alright. Where are they all from? They're all from various different places. Let's just be friends with all of them. Hello. Anybody doing Rust will gladly follow. I don't know what following means, to be honest. We're going to form the Rust League and hope there's some competition where everyone doing Rust wins everything. That is until I get Leaf far enough that we can have a Leaf League. This is curious, he's level 5 and he's pretty far behind, but he's jumped right into the competition. Good for you, Ramikun, that you actually just went ahead and did competition without doing any of the practice stuff. That's great. And where are we now? We're at 46. And we're actually slowly going up. We might actually make it to the next lead, but it gets harder as you go higher up. And I wasn't anticipating waiting this long. So yeah, guys, make sure you please tweet about my shows and stuff if you want to get some more viewers. Post me on Reddit, wherever you want. Follow me, subscribe to me if you want. I have YouTube as well. Be sure to like the videos, like anything, anywhere. It really helps me out. Any of your likes, any of your retweets, any of your subscribes, follows, all that stuff. This all helps me out a lot. We can get some more viewers, make it more interesting. So please do that. At this point, we're just going to sort of babysit the show and watch where we go up. We're at 40. We're slowing down here, and we know the basic fix we have to do. We're going to clean up the dead people. Then we're going to have to maybe do a look ahead. We don't know. Probably help a lot. One step look ahead or a dead zone would help us in many cases. And but this value going back and down, up and down here pretty much means we're probably not going to make it to the Gold League. We're actually going to have to do a few fixes first, and I suspect just clearing out the dead people might be just enough, because we're really close. If we just clear out the dead people, and then from there, just doing the one-step look ahead might be enough, and so we're not getting anywhere. So I don't think I'm going to watch this anymore. I think I'm done for the evening. I had fun. We made it quite far. I'm glad you were all watching, and again, subscribe, follow, retweet, like, all that wonderful stuff. It all helps me out a lot. And watch the other people that I follow as well, and the people I auto-host, and it was been a good night. Tomorrow I'll be here at 3 in the afternoon Berlin time with Fuse apps and training and stuff, and you can join that as well. It's something completely different. We do C# there, and I'm mainly in charge of layouts and animations, and I hope you enjoy it. If we happen to get to the next league, I'll tweet it, but I don't think we will because it's going up and down. So thank you very much, and we'll see you next time later this week if you don't join into the earlier broadcasts. Enjoy.